I will start the presentation, and while it is loading, yes, it is on. So I will start. So I will start the presentation with introduction about the project within which this final conference is has been organized, and so it is GlassCircle, exploring full cycle. No, it's not done, but it's gonna be soon. So basically, the project is about trying to find the solutions for glass fiber residue that is produced within the industry. And this is the final conference. So let's move. Okay. Exploring full cycle circular economy for glass fiber industry. So the background. So how did we get here? So first, there were several people, key people who are here, which already thought that during glass fiber manufacturing process, a lot of residue is generated, and most of this residue goes directly to landfill. Which is unfortunate, because if you look at some of this material, you can see here, this is some residue, and you can see it's relatively good material, because when we thought about this residue, I thought it's going to be like a dust, something unhandleable, but these looks like a very nice fibers. So we thought, why this should go to the waste? I think the best way to be to give it to someone for use. So the objective was of our project is to create a strong cluster that consists of key players within the industry, which is manufacturers, users, end users, recyclers, policymakers, and bring them together, all three key people from industry, experts and scientists, and also public authorities to exchange knowledge, discuss the possible solutions and necessary next steps for faster change of this industry to circular economy. This is the consortium. So we consist of 6 partners. The project lead partner is Riga Technical University, and I'm the project coordinator here. But we have very nice partners from Luleå University of Technology in Sweden, then another university in Denmark, Aarhus University, Podcomp, and then we have 2 industrial partners, Podcomp and Hitachi Energy. And you will hear a presentation from Hitachi Energy a little bit later. And lastly, but not least, we have Valmiera Municipality. And why we chose them is because we have a very large glass fiber manufacturing in Valmiera. So they are very interested in this subject. What has happened in the project? We have had some great events already done, and this is just the final event. So we had the hackathon where we had the students for 24 hours to try to find a solution, try to find some kind of application for these fibers and residue. And you can see some nice images. It was very interesting event. I was not expecting such a great involvement of students, but students were really active and really interested in working. They were working really hard day and night, and we also it was nice that Valmiera Glass joined us, and they gave very nice prizes for the students, so probably some extra motivation for them. And actually, you can see here are the winners, Maria and Augustin. And if you will keep around at 11:10, they will present their idea and what has happened after the hackathon with them. So then we have a workshop on environmental and economical feasibility to recover glass fibers. So we had some success stories, and also we had some LCA analysis. And you can still find some of the presentations in the project webpage. You will see later. But yeah, it was a very good discussion. Again, It's all about bringing people together and discussing this issue, because sometimes it feels sometimes annoying to discuss, but I have recently learned the more you discuss, the much faster is the implementation process, because you can kind of resolve all the possible ways that the things go wrong. Then we have a workshop on business model co-creation. And again, if you will stick around, Mikael will give some more information about what happened there. We had a survey of communities about circularity of glass fiber. So we basically asked the general public what they think about it. And again, if you will stick around at 12:40, Līga Bieziņa will tell of the results. And some of them I think is very interesting, at least from my perspective. And lastly, let's see if I can press play, maybe Richard. We are creating database, but the best way how to show it is with the video. So let's just watch. Pause, please. So a little bit more about this database. So basically we are connecting companies which are producing this residue, and we have estimated, not we, but there is some estimations that around 10 to 20% of the fibers of the mat which comes into the industry directly goes to the waste, which is kind of sad and I think ineffective. So we are creating database where these companies who have this residue would share, could be shared, but maybe sell for a cheaper price to the companies which do not need maybe large amounts. So because some of the residue we found out it's basically 2 meters by 80 centimeters. That's a big piece that you can make actually something great about it. And some of the companies which are even better is that they are already trying to use this residue within the company itself and trying to come up with a new products. So this database will collect the information of the companies that produce this waste and companies that are looking for a smaller amount, and they can maybe have some connections there. And another thing, which I will show a little bit video, we have actual success story in this regard. Martin Šrubenis, who is the coach and chief of engineering of the Latvian national luge team, and he's also a bronze medalist. So we asked him to be as a consultant in hackathon. And when he saw the waste, he said, "Oh, can we get some of this to see if we can make out something?" And he said, we contacted the company who from which we got the waste, and he actually got the piece, and he actually made a luge, part of the luge with it. And so maybe if you can press play, you can hear a little bit more. Geometry of the glass fiber. So that's why we not always need those big sheets to produce something. And, we actually take care of the material we have. So big company can share the material that they already don't need, and we can still build some sled and give it the second life. So it's a win-win situation. Mm-hmm. Glass fiber waste is minimal thanks to collaborative efforts. Join us in creating a sustainable future. Visit our website to learn more about GlassCircle and how you can get involved. Mm-hmm. So this was something we were really happy about, that we had people who actually resonated with the idea. So if you, now I cannot switch the slides. Yes, so if you know anyone who would like to join the database, it's still possible. We will, even after the project ends, we will have one more round where everybody who has joined the database, signed up for the database, we will put them on within the database. So basically how it works, you have a survey, you fill it in, and then we add it to the survey, not survey, to the database, and you can then connect with the other people. What else? No, it doesn't work. Yes, so you don't see, but maybe you can, but I recently went to the courses and they were talking about what is needed for a change. And there are three main things. So basically authority, power, and influence. And there is some Richards, please. Yes. So there is something called CAPI, which is called coalesced authority, power, and influence. So basically, in order for any change to happen, you need all three components. So all this coalesced. So basically, it's very fancy words for coming together. So basically, all three components has to be there in order to have change. So basically, authority, policymakers, power, companies, industry, and influence, basic academia. So if we all three of them have together, we talk and discuss, we can have a solution. So so that's why we are here. So we have a final conference, and we have all three of those components. We will have industry, we have policymakers. I'm even very happy that we will have waste management policies at EU level from European Waste Management Association, which is, I think, a great addition to our program. So we have CAPI in the room. So what I would urge is, so let's make the change happen since we are here. So thank you. And I will be chairing now the first session. So Viktoria from Tallinn University of Technology, she will talk about life cycle analysis, which is, I think, very important thing if we want to actually measure how environmentally friendly anything is. So Viktoria, thank you. The floor is yours.
Yes, thank you very much. Can you hear me? I hope.
Yes.
Okay, thank you. So just a second, I will share my screen. Okay, I don't know, can you, yeah, can you?
Yes, we can see, it's perfect, thank you.
Good morning, my name is Viktoria Voronova. I'm coming from Tallinn University of Technology, Institute of Water and Environmental Engineering. And I have long-term experience in teaching of life cycle assessment and also conducting several projects in this area. And today I would like to share with you how life cycle assessment as a tool can be used and what benefits it brings for the companies in evaluation of their environmental impact for different products or processes. So what the life cycle assessment is? By definition, it's a quite practical tool which helps us to evaluate the environmental impacts in the entire value chain of the product. What does it mean? It means that we start from the raw material extraction, including their transportation and processing, and then transporting them to the production stage and evaluating the impact from the production of different products. Also the packaging and distribution stages, if it's needed, and the essentials for specific product can be included into evaluation. And also the second part, the downstream processes here include the use and maintenance phases and also disposal. But here also I should mention that such processes as reuse and recycling can be included as well. And of course, we can evaluate the end-of-life options, which means different kind of waste treatment, such as, for example, incineration, options with energy recovery, landfilling, different kind of biological treatments, etc. And if we look in generally to the industrial companies nowadays, they of course are obliged to fulfill all environmental regulations. And we speak here about European Union level. They have quite strict and more strict regulations regarding the environmental. And all companies have to control the emissions. What does it mean? It means that end-of-pipe solutions not enough anymore, and companies have to be more proactive. They should, let's say, move toward to the sustainability. And you know probably that European Union prepared also the package for the companies to make the sustainability strategy and report it. What does it mean? Again, that companies should try to include into evaluation the whole aspects, environmental, social, and economic. And when we speak about environmental part and environmental aspects, of course, here I have to highlight that the life cycle assessment tool will be very helpful because it helps the companies evaluate the environmental impact in their entire value chain, including the raw material production and impact from that, production of their own product, and then the downstream processes such as use and end-of-life options. And of course, find out the major places for reductions and helping. This tool can help also to define the reduction opportunities. And looking to the life cycle assessment and how to start with it, there are two main approaches that can be used. One is called cradle-to-gate approach, which is a bit simplified evaluation, which include only upstream processes, starting from raw material extraction, product manufacturing, packaging, and then stop at the company gate. So it doesn't go further and not looking to the use and disposal stages. And there are another approach, which we call cradle-to-grave approach, which allows companies to do the full-scale evaluations from raw material extraction until disposal stage, which of course requires more time, more complex process, especially for the use stage. Then sometimes the data availability could be a bit limited and difficult to get. But what is the environmental impact and how it can be measured in terms of life cycle assessment approach? Environmental impact usually refers to the direct effect of different socioeconomic activities and natural events on the components of the environment and human health. And when we speak about life cycle assessment and use it as a tool, the environmental impact can be measured using different environmental indicators. And the selection of those indicators very much depends on the methodology selected. But nowadays, common methodologies use different approaches. And for example, if we select the midpoint level approach, there are, let's say, at least 13 up to 16 different environmental impact categories can be evaluated. And here you can see some examples in this feature of different environmental indicators. And probably one of the most known nowadays, this is the evaluation of the climate change or global warming potential indicator, which is evaluate the environmental impact of the greenhouse gases to the climate change. And usually in these specific categories, the reference substance is carbon dioxide and all other greenhouse gases are calculated in reference to that. And there are also other categories which helps us to evaluate the environmental impact of the air pollution, such as ozone depletion, ionizing radiation, photochemical ozone formation, and particulate matter, which is most commonly used Also, there is possibility to evaluate the environmental impact to water bodies using, for example, such environmental indicators as acidification, eutrophication. Here you can see marine and freshwater, and also we can evaluate the water use. Also, we can evaluate and model the human toxicity and freshwater or ecotoxicity potentials, land use, and resource use. And resources, as you can see, we can select and evaluate the use of mineral resources and also fossil resources, which is for some specific products a very important category as well. And life cycle assessment is a standardized procedure. Actually, it relies on two main classical standards developed by Aizea organization. It's 40,040 and 40,044. And the standard 40,040 set up the main principles and framework for LCA, and 40,004, this is a more detailed standard which provides step-by-step guidelines how to conduct the LCA. In life cycle assessment, there are four main stages, and the evaluation starts with definition of goal and scope or purpose of the study. Then the second stage called life cycle inventory, and this stage includes the data collection, probably the most time-consuming stage. And then we go to the life cycle impact assessment part, where we calculate the environmental impact within the selected environmental indicators that I presented to you in a previous slide. And then the last stage, result interpretation stage. And there is also possibility, because as I mentioned previously, nowadays are companies more and more interested in evaluation of their environmental performances. And there is a bit, let's say, simplified approach if the company is, for example, interested more to be focused only on the carbon footprint of the product. What does it mean? It means that our carbon footprint of the product is very much connected with the climate change and global warming potential calculation and based on the same methodology. Therefore, Aizea organization was developed separate standard, 40,067, which only focused on the evaluation of carbon footprint for the product. And this standard provides actually the guidelines how to calculate the greenhouse gas emissions, but those emissions also associated with the whole life cycle of the product, meaning we calculate them from raw material extraction until the disposal stage. So we can say that the standard is totally in line with the principles of life cycle assessment main classical standards, but focus only on the carbon-related emissions, on one, let's say, focusing only on one environmental indicator in that case. And continuing this topic, maybe I would like to a bit show how actually this climate change and global warming potential is calculated. The calculation procedure is quite simple, and it was developed by Intergovernmental Panel of Climate Change, this methodology, and nowadays it's implemented almost in all methodologies which is used in life cycle assessment. So the calculation is that the climate change impact or global warming potential, we took the mass of our substances or product and multiplying those to the greenhouse gases released or emission factors, which is already provided by IPCC for the 100-year global warming potential. And the units of such calculations are kilogram of CO2 equivalents per kilogram of CO2 emissions. And if we look more closely, what are the main greenhouse gases which is contributing to the global warming? The main of them are carbon dioxide, and this gas is taken as a reference. And all other gases such as methane, nitrous oxides, and halocarbons, which are hydrocarbons which contain chlorine, fluorine, and bromine, are calculated based on referring to carbon dioxide emissions. So the idea behind the greenhouse gas effects is that all solar radiation which coming from the sun should be reflected back to the space. But due to the greenhouse gases, the solar radiation is absorbed and re-emitted in all directions by the atmosphere by warming the Earth, causing by those the greenhouse gas effects. And as I mentioned, Intergovernmental Panel of Climate Change have developed the methodology how to calculate those emissions in CO2 equivalents. And as you can see here in table 1, these are emission factors which were developed during the time. And as you can see, the carbon dioxide is always 1 as a reference substance, but other emissions are slightly changed. In the beginning, for example, in the first developments, which mean that the second assessment report was developed, they provided for methane, for example, that it has 21 times more effect in comparison with carbon dioxide in the atmosphere, causing the climate change or greenhouse gas effect. But in the fifth assessment report, this number is increased. So if you would like to do calculations now, you have to use already emission factor 28. And for nitrous oxide, for example, the picture is slightly different. In the beginning of development, the emission factor was 310. And if you look to the final fifth assessment report, the factor decreased to 265 times in comparison with carbon dioxide emissions. And I would like to present you also one example, what we did. A calculation of carbon footprint for green events in Estonia, and this was also done in the frame of one Interreg Baltiplast project. And this project is still going on, which means that we continue with those different approaches and calculations, but I think this topic is quite suitable just for this event here. So the main objective was to calculate the carbon footprint of reusable plastic dishware, which is used at green events in Estonia, and compare it with, in case if instead of them we use single-use plastics. We were focusing more on the production of the materials, including their end-of-life options. And as you can see here, we selected 6 events which conducted in Tallinn between 2022 and 2023. And the most probably biggest one is Yav Song and Dance celebration in Estonia because of the amount of people. And our approach was to collect the data from the green event. The data included number of visitors and number of reusable cups, plates, and cutlery used in the event. And also additionally, we collected the data from a catering service. First, we needed such information as number of reusable cycles, type of a dishwasher, and we also included amount of water and electricity used during the dishwashing. And also what is important to include the defect rate. And similarly, we created the scenario, alternative scenario, if we use single-use plastic. For example, with the same number of visitors, but only instead of reusable, we used single-use all the time. So the conditions that we created were the same for all scenarios. And for methodological part, we very detailed look to the materials, what all components of dishware have, I mean cutlery, plates and cups. Some of them were even from biomaterials, some of them were fossil-based or wood fibers, as you can see here. And we find out the emission factors. Most of them, as you can see, are found from European Union Life Cycle Assessment Database. But some of them, for example, for bio polypropylene, we faced some complications to find out. And it was taken from scientific paper where actually were different methodological and different papers evaluated. We took kind of an average. So probably nowadays for these biomaterials, the factors are not so certain, and most of them can be found in different research areas. And later on, we collected the data from each event, as I mentioned before, for cups, plates, and cutlery used, their amounts, materials used, and similarly created a comparative scenario with the data of single-use plastic. And also obtained the data about the dishwasher, for example, amount of electricity used for total loading and blow drying, and also emission factor, what we used for electricity as far as all those events were in Estonia and catering company were from Estonia. We used actually Estonian residual emission factor for electricity, which is published by Elering. And as you can see, it's quite high, 0.715 kilogram CO2 equivalents, again, due to the share of oil shale in our Estonian electricity from the grid. And our approach was, we defined the functional unit as 100 events or 100 Voronova cycles for the reusable scenario. And similarly, then we calculated that single-use plastic will be used during 100 events. So here you can see this, how this methodological approach were used. And of course, we included also the defect rate because we discussed with catering companies that it's not 100% when they reuse the dishwasher in the dishwasher, and also during the event there are some losses, and these losses are in amount of 3 to 5% depending from the event. And for Sundance Festival, they told it was a bit higher, 5%, but for smaller events, we can keep like 3% of the defect rate. And the result shows that in the case of reusable dishwasher, the total contribution to the global warming potential climate change category in tons of CO2 equivalent is about 5 to 7 times less than in case of single-use plastic for all events. And of course, within this Baltiplast project, we continue evaluating the environmental impact from the green events, and we would like to include also other Baltic Sea countries, our partners who will provide the data, and probably we will see more better picture across the Baltic Sea region in regard on that. And I would like to highlight also the benefits for the company using the life cycle assessment approach. The most important that companies will give the possibility to evaluate their environmental impacts in entire whole value chain, and then provide the reductions if it's needed. For example, for some resources, in energy use and emissions, you will find out exact places in your value chain and can provide new opportunities for that. Then also life cycle assessment provide comprehensive framework to assess and report environmental performances, of course, in compliance with current regulations. And implementation of the LCA definitely will help also to be better prepared for the changes in the future regulatory requirements. Also, implementation of LCA can bring competitive advantage in markets, investors and partners who, for example, prioritize environmental responsibility. Especially now, I think this drive, let's say, comes from banking sector. Then they ask, once you would like to get the loan, please show how responsible you are, what is your carbon footprint, etc. Also, probably LCA will help better to communicate the data, environmental data, because as you understood, this is the tool which allows companies to quantify the emissions, not only in qualitative way, but also in quantitatively present the result. And also, definitely, it helps organizations move towards circular economy principles, because it includes also possibilities and evaluating in recycling, reuse, and resource recovery, and provide the reductions for the companies. How to learn? What are the learning opportunities? I would like to invite all of you to look in cooperation also with our Riga Technical University, our Latvian partner. We are in development of educational platform for life cycle assessment structure called Epicenter. And now we have this Epicenter project, which is funded by AT Raw Material. And in the frame of this project, we will provide two-level courses. And the first basic level course will give you also some credit points if you're interested. It consists of online pre-course and then on-site basic course about 2 days in a summer school, and of course part of independent work, and will include some mentoring. And there will be possibility to continue in advanced course, which will include sustainability assessment and business economic assessment. And actually, this is the schedule. Usually this basic course starts a bit before, 1 to 3 months before of this contact course or summer school course. And then the advanced course are more related to on-site school. Altogether, it takes about 5 days. Plus 1 day for socialization that we prove, and at the end there will be some time for independent work to finalize the project and present the results on the final online seminar. And the platform that we will use, this is the Taltech platform, where all the materials will be kept, and this will be e-course first for the basic level, so you will have a lot of videos, PowerPoint slides, all the explanations will be provided there. Now, this is our roadmap, how to get it, and maybe to mention once more that there will be possibility, of course, to get the certificate at the end. And maybe the first summer school is planned to be conducted next September 2025 in Riga. And if some of you interested to develop the skills, to be more aware of how to make such calculations, you are very much welcome. And here I have a link to our Epicenter project where you can actually register for the newsletter, and you definitely will get all relevant information about the registrations and deadlines when the registration will happen. And I think that's all from me. Thank you very much. And if you have any questions, please, you are welcome.
So thank you, Viktoria. So questions? Nothing from audience, maybe somebody from online? So my question is, where do you see the biggest challenge moving to circular economy when looking at the LCA data? What is the biggest thing that where companies fail to be environmentally friendly?
I think that the most problem that, at least on my practical experience, we found, this is the data. This is the data and how, because company there have their own data, but when we want to evaluate upstream, like for example raw material data, then they should contact their suppliers. Or if we want to evaluate downstream, they should contact or collect the data from consumers, from statistics, etc., which is quite complicated sometimes. And therefore, the most complex part to do this full life cycle evaluation and the data quality, I mean. And of course, maybe the second point also, this is the economical point of view, because experience as well, no? Because companies themselves probably not able to conduct such comprehensive study, and they have to find out LCA expert in that, and plus the expert should be also be able to evaluate specific their value chain, and sometimes also it could be quite problematic, in my opinion. Therefore, I think it's really more, let's say, courses are needed now to try to teach industrial representative students to use life cycle assessment as a tool, and people should be with different backgrounds that they have these possibilities.
Thank you, Viktoria. Maybe some more questions from audience? No, haven't I inspired anyone? We still have 2 minutes until the next presentation, so I will go ahead and ask another question. Maybe where do you see policymakers, how they can help moving forward? Because I know that LCA, there is standards, but people interpret the standard rather vaguely sometimes. So can you maybe comment on this?
Yes, because you are right. At the moment, those standards are all voluntary. There are no kind of strict regulations. But, nowadays, for example, in construction sector, I know that in Estonia already in 1 year, since 2000, even I think in July 2025, they will implement in construction sector the regulatory framework obligatory to calculate carbon footprint for the buildings. I don't know how it's in Latvia now in construction sector. Yes, but Estonia it became obligatory, and of course our government did a lot. They developed the methodology, databases. It's a very, very huge work, and it's not even yet done by the end. They have done quite large preparations to do it, because when the regulatory come into force, of course, all companies will oblige to calculate for each building. I think it starts from the building size 1,000 square meters, but it's already in 1 year, and it's raised a lot of questions how to do it and what to do. Therefore, I think, yes, regulatory bodies and governmental bodies can very much support in development of databases, local databases, which is very important when we speak, and yes, providing some methodological, guidelines for calculations. No, in different sectors, sector-specific calculations, I can say.
Thank you. I think this is very very necessary input, and that's why again we need all three parties to come together and talk.
Yes.
For this, I thank again Viktoria for the speech.
Yes.
And
thank you very much just for inviting me. Thank you.
Yeah, it was a pleasure.
A presentation. What could be this presentation without presenting us, like who we are? We are we. As Robert introduced, as Robert says, like we are two ex-formers from the EI James School, which is a real European school of material engineering in France, which have a partnership with the LTU. And we used to have like a particularity to be in a sandwich school program, which was like 50% between company and school, alternating each 3 months. Maria was working at the National French Institute of Solar Energy when I was working at Nicomatic, an electronic company. During like this 3 years degree, we went at the Luleå Technical University for 3 months under Robert responsibility supervisions, and he offered us a possibility to participate to this hackathon. Meanwhile, we were working on a lab project.
So to go further, hackathon is an event where individuals or team collaborate to create a solution on a topic within a limited time frame. So it could be typically 24 to 48 hours. And it brings for the participant the capacity to innovate, prototype new solutions, learn also new skills, and very often compete for prizes. Also, it allows the participants to use their creativity and teamwork in a very dynamic environment. So in our case, the idea was to imagine a concept of a product that would reuse the manufacturer's glass fiber waste. And however, the solution needed to be feasible, to be as feasible as possible on technical and business aspects. So to give you an idea of the schedule, so when the hackathon started on the Wednesday and ended on Friday at lunchtime, so we had approximately 48 hours to do that, and we realized that the 48 hours were really shorter than we thought, because in this amount of time we had to make our own idea, to organize ourselves, and also to kind of get rid of the limitation that we were constructing in our minds. And we had to let every idea possible, and to let every idea to be possible, to be a possibility. And also we had to make a proof of concept to demonstrate the feasibility. So each steps were related to different goals, which were represented for us by the skill we require in order to not being either stopped or blocked. And in our opinion, the worst part was the first one, due to the fact that we were a purely technical team, so we had really a lot of practical skills. And the fact that we had to create an idea from the zero was the trigger point for us. And usually in our studies, in our academic career, we had the starting point that helped us to create the idea. And there we had to use our fully creative minds to start this idea, to create this idea. But at some point we defined our concept and our idea, and then we were unstoppable. And behind each skill, it was possible to define four jobs, 4 roles in our 48 hours rush. So both of us had to be, at the time, the technical expert, which was in charge of the feasibility, the storyteller, which will manage how to create the final pitch and the concept and the story behind the idea, and also the project manager, which was in charge of all the deliverable that we had to provide, and last but not least, the art designer that would enhance the project by the creativity, by bringing creativity. And so we had to manage between all these roles, and we also had to switch. We didn't have any defined roles in our project, and everything was not all the time simple, because we could be not really comfortable with one role, or so all of this was kind of a challenge.
Yeah. Yeah. Sorry. So to continue, we'll talk a bit more about the resources we used, to be straight with our idea, and to go straight to the point without doubling. And yeah. So when we start, I asked Maria, do you think we can use some old stuff? To use some old stuff I used to have in art school, and she was like, yes, let's go. So I will present you what is a retrovalent code, which is a method which can be compared to the apt one for mechanical engineering people, but this one is for RT people. Like the tetravalent code, like is a framework used in design to create more meaningful product for a situation. Like it emphasizes on 4 key dimensions, which are named sometimes codes. They are like the concept, the aesthetics, the technique, and the ethic, the guideline behind the project. And it encourages designers to consider how each aspect interact and influence on the other, like leading to more holistic and innovative solution. It balances this element balance to add more than just one topic. Like you will have more disciplines integrated in, and you will have participant you will let to each participant to give their point of view, like not thinking on one straight thing. Like that's what we talk about with all the personnel. And we used this one, as I said before, in contradiction as an apt method, which is for us like less useful when we need to create stuff. And on my opinion, it matched very well with the principle of circular economy, which are like the model which focus on reducing the waste and maximizing the use of product. Like unlike traditional linear approach, it helps to use the guideline like take, make, and dispose, and it promotes like the recycling and restoring material, which was the case of the project, the case of the hackathon. With this kind of models, we can develop new models and encourage to like the durable, the repairable, and recyclable. So the direct consequence was to minimize the environmental impact and fostering of innovative and creation new business opportunities. As we were in the polymeric group section at the LTU Technology University, we were able to use the laboratory to perform our prototype. And we had like an access to additional materials that were needed, such as epoxy resin, paint, and molds, and the lab equipments, fume, huge stick tables, and an oven, and so on. And also the very helpful help of Zainab, which was very, very helpful during this time.
So after this whole introduction on the project resource, we'll go further in the details on what we made, adding all the purpose next to it. So as maybe maybe all of us here know, glass fibers is strong, a lightweight material, and is often made into a woven fabric or combined with resins to form, most of the times, composites. And they are used for the superior strength to weight ratio, durability, also corrosion resistance, design flexibility that they have, and it makes them ideal for application in various industries such as aerospace, automotive, construction, and various other industry that we know. And as an example, we have the automotive sector that employs glass fibers that for some of the parts that require reduced weight without sacrificing any strength or any mechanical properties, also improving the fuel efficiency. And in our case, we decided to pursue with the boats and marina industry, so the nautic industry. And the main reasons for that were because the GlassCircle project concerned the Baltic Sea, and in this way we thought that it was a good field to relate with it. So what could we create to reduce a pain from a casual situation? By thinking of our little experience with boat, we realized that regular sailors didn't really have a storage in the harbor at the spot where their boat is. And so we thought about creating one. But maybe we thought also that a simple storage may not be enough or attractive to be sold or for the people. And to go further, we decided that it will be a storage where you can also sit on it. It can be also a seat. So you can use it to change your shoes or anything else before and after going sailing or going to any nautical activity. Also related to the aesthetic that we wanted to bring to the product, the idea was to relate, to do a wavy shape, to make a reference to the sea or the ocean, and also using a local process, so the hand layup, the wet layup, or the infusion. So to pursue on the circular economy, as Augustin talked about it later, before, the purpose was to reuse, as we said, the non-desirable waste from the glass fibers manufacture, and it means that for the orders, the producer don't need to create a special batch and can sell the waste. And due to the fact that in the nautic industry, there are also other glass fibers users, a unique order can be done inside the casual use woven in also the waste to create the storage. And while we were thinking about our idea, the weakest point of our system was the materials that we used, and it is tough to recycle, and have at the same time a reinforced durability. So if we weren't capable to reprocess the waste, using all the parts the longest time possible was the main point here in our idea. And also it means that we had to think about a simple design for our idea, and with parts that would be easy to change or to replace. So the thing is, what could be such a project without thinking about a business model? So as we said before, the waste of the manufacturer will be used to create the products. So the thing is, with which person, who we will perform this product, who will help us to manufacture it. So in our minds, it was good to introduce the ecosystem collaboration. So it means that the local center of expertise of the nautical industry can provide practical lectures on how to use the glass fibers. And one of the practical activity could be this storage or the product that we could invent in the future, but in the first place, the storage that we thought about, and which then can be sold to the other sailors or tourists or any person that could be passionate about nautical activities. So another interesting point is that we will create freshly new glass fiber specialists inside this center of expertise, and then they would be capable to spread this concept and reuse the glass fiber waste inside the factories. And in our opinion, what could be a circular economy or sustainable initiative without thinking about the ecosystem around the topic?
So on purpose, like we talk a lot about the concept, but we didn't show any pictures of what we have done as like the product. Like it was just to emphasize sound. So like when we were thinking, like we imagine a sailor, a passionate person about a personal storage box next to his boat, like to be capable to change itself, like as a comfort, because it will avoid like to take their belonging inside of the boat. Like most of the time, like you might not have as much as space as you want, so it was an idea. And this locker we thought that we were capable to install this locker inside of the pontoon. So that was the use case and the idea of the project. Like if you can see on the product, like there is wavy shapes on it, like we talk about it later. Yeah, like on the side, it helped. And to be more straight about like this eco design stuff, we thought about like this exploding view, having like 3 pillars like to sustain people weight, because you can sit on it if you want, and having like a shell all around to protect from wind, water, which was salty water, and the fact is that epoxy glass fiber are chemically resistant, so it used to help, and having something which wasn't too much ugly, like to let people buy it. So that was our goal. So as a concrete stuff, we try inside of the lab to make some prototype of this wavy shape, like using some wovens. It wasn't as successful as we expect, but it was like extremely funny to do it, like to try with some cup boards to create like this wavy shape, create the molds and prototype it. So we realized that it was possible to make some shape with glass fiber. So it means that it's possible to create the shape, the shell all around. It was a wet layup, so it means that technically it's possible. Like we need to test on if it technically we can sustain someone with this kind of system, but that will be for another hackathon.
To conclude on this presentation, participate in the hackathon allowed both of us to think about how a local actor or local manufacturer can be part of the sustainable development, and also it was really interesting for us because we had the opportunity to add more concrete applications to our theoretical material expertise that we had thanks to our academic career. And also through these hackathons, this hackathons was also the possibility to provide a new vision to the project, and it was a great opportunity to bring this new vision and also to participate on the project.
At the end of this like 48-hour fun, like we realized that we won the first prize, and it was unexpected because for us it was just like fun, and we were so glad to realize that the jury was totally in phase with us, like 100% eye to eyes. So to put it in a nutshell, like this hackathon was our possibility to try sustainable tomorrow, and also to think outside of our expertises, which is, on our opinion, like what we need if we want to work tomorrow in a company. So it was a good way to approach that.
So as for we will now give a bit of our updates about ourselves after the hackathon and also today. I mean, today more actual updates. So for my part, after the hackathon, I continued working as an apprentice in my company while also following the classes in school for my last year of master. And in March, I came back to Luleå because I had the opportunity to start a 3-month internship at LTU under the supervision of Robert Joffe and Zainab Al-Magdasi, which was a really, really interesting internship. And I had also the immense honor and opportunity to present at the ESSM conference. So I also wanted to thank again my supervisor for that, because it was really amazing. And to give you a more recent update, so as Robert said at the beginning of the presentation, I presented, and also Augustin, I presented both my apprenticeship and internship for the final defense, which was last week, I think. And the official graduation is now approaching soon. And in the future, I want to continue to contribute in a more sustainable work by working either in recycling of polymer materials or working on new materials that can be recycled easily or that are more sustainable, and all of that in my future work, in my future job.
And on my case, like after the hackathon, like as well, I continue to work with my company. And right after like the summer of the hackathon, I start with my company to create a sustainable team, like to think more about the impact of our product. And at the very start, I was in charge about like all the aspects around the LCA. Well, nowadays I wasn't capable to pursue because we just have like 24 hours per day, so I cannot do everything, but like I used to help to create that. And if I can give you a very tiny example of what we have done, meanwhile, we try like to use regenerative material, like to think about, yeah, okay, we're doing like electronical component, which is a connector, like such as USB port, and what it could be if we can change some of them using material which can be like we can sustain in all along the time. And the project is still going on, but like it's a very good state of mind which can be compared to what we have done with the hackathon, to let's think about the future. So it let me have like more passion about this kind of stuff. And for my future, like I will go to Singapore working 2 years, like to help the hub, the Asian hub of my company, to think more about how we can manage material, like as technical data, but also as a product we can process, to include aspects such as eco-design and reduce the cost as well. So it will be a new challenge because I will do some change management in kind of way, and I don't know what it is, but I will try and succeed. So yeah. If you have any question, like feel free, that's your time. If you don't have, we can have question for you, but you will need to answer, so ask questions.
Thank you very much.
You're welcome.
Speakers, Maria and Augustin, and we have few minutes for questions. But before going there, I just would like to comment. We are very happy that we had those students, and we are very happy they did their job also in hackathon. Sorry, I'll manage later on. Yeah, I mean, one of the examples here, first of all, what we can bring out, in my opinion, that making things from glass fiber can be fun, and it should be fun, you see. And also that actually it should be maybe sometimes art and technology together in order to come up with something interesting. That's what our students actually demonstrate. Do you have any questions? No? Okay, I will have a question. You showed these composites, composite parts, these wavy parts, and with expertise in composite, and I think others agree, they look somewhat not as a good composites. But how did you make them? I mean, it was a first trial, very impressive anyways. We didn't expect that it actually will be something done in the lab, but it was very impressive. So what did you do? How did you create them?
So yeah, to create them, like during this time, like we were in a project, like, so Maria was working with Zainab on projects. So she was she used to learn how to like or to react to epoxy stuff. And in my past, I used to work a bit with glass fibers. So we combine our two knowledge to just say, okay, let's put some glass fiber, create a ratio of like 50-50 in volume to just put it and layer by layer, such as what we do with glue and paper, add the epoxy between each layer, each glass fiber woven, and put like some texture behind to create the shape. So we use like some, we use the Coca glass fiber, the Coca cupboard you have like in the drawer. We cut it in half and put it in different form to create like the shape, and we put the woven, and that was the thing.
So you also had a creativity in making
Yeah.
the mold. That's very good.
It was more creativity at this moment than technical thought.
Right. And I can see also that you have used also different types of fabrics in this, or is it just one type which contains different arrangement of fibers?
Yeah,
How
we
was it
use
to do
an anisotropic one and a woven one, like.
Okay. So
Yeah, we
basically you
started.
could use. Yes, go ahead.
We started with the, if I remember correctly, we started with the woven on the mold, and then we added the non-isotropic fibers.
Okay.
If I remember.
So basically you could use actually multiple types of fibers which coming from different places, because this is really, I mean, it's not really structural component, but it's also good that you can utilize all kind of fibers in this. That's also a good thing. So last chance, any questions, comments here? Well, if not, once again, Augustin, Maria, thank you very much for participating, and thank you very much for telling us what you have done. Really good job. Thanks, and good luck in your future work
Thank you very
and
much.
studies.
Thank you very
you
much.
very
You're
much.
welcome.
Okay, so now it's time to move on to the next presentation, and we are going to have presentation by Uldis Skrebs from AG Power, please.
Hello, everyone. I'm Uldis Skrebs from the company AG Power. I will talk more about textiles and tires. We are a company. One second. Nope. Yes. AG Power Group is the leading private-owned company of energy in Latvia, and also we are in waste management and natural resource tax. Here you can see our data. I will not read everything about it, but we are focusing in green energy and to keep the country green, and we are pretty successful with it. Here are some companies, what we are doing. One of the green energy is solar power energy. We are setting all over the country solar energy projects. Also, we are in gas trading, electricity trading, and as you see, in recycling, which is waste management and natural tax. Yes, these are products which we are dealing, which we are collecting and getting in a recycling system, which I will show you. It's textile products, electronic equipment, packaging, which we can, before speakers from Tallinn were mentioning, we also are dealing in that. I wanted to mention it's a very hard process to do it, and in tires. Yes, we are 100% controlled by the Environment Service of Latvia. So to understand more, there are only few companies which have all permits and which have the possibility to do it in Latvia, because they are controlling it really hard. So it all is counted, every kilogram which you have collected and what you are doing it and where is it going. Yes, I will talk more about tires. These are each year in Latvia 16,000 tons of tires produced, which are wore off. 1,500 tons of tires are collected in landfill sites. These we could say are historical tires, which are all the time appearing from nowhere, from old garages on hangars. No one can explain it, even the environment ministry can't explain it, but they are coming out somewhere. We are now collecting 60 till 80% of these tires in Latvia. And we are creating the possibility for every Latvian citizen to give free tires to us. So they don't keep them in their garages or rooms or wherever, but they have the possibility to bring them to us and we will get rid of them in the right way. Yes, these are our growings. From 2020, we had approximately 4,500 tons collected in Latvia. And this year we are close to the numbers already to 10,000 tons. We are working with 200 more companies in this industry, starting from other waste management companies to the sellers, for example, Goodyear, Bridgestone, which are importing the goods in Latvia. Yes, so as I mentioned, we have more than 200 companies, all workshops, everything, and we have found a collection system and in our yard. The yard is in Riga, based in the center, let's say in heart of Latvia. Because of the logistics, we also want to see the green side of transportation. We don't want to drive around all the country. So we found the best solution in Riga as a center. From the logistic side, also we created an ETS solution and customer database. So we know every kilogram that is sold in Latvia in tires imported and sold, and where it's distributed and where we are picking it up, like to see the life of the tires, how they are going and where they are keeping. But we have to keep in mind that some people drive the tires wear off in 1 year, other in 5 years. So the statistic is very flowing. It's like changing all the time, depends also on the economic situation. Like in the COVID times, the numbers plumbed, like everyone was saving money, were working from home, so they didn't drive so much. Also the transportation was lower. So every year it's interesting to see the data, how the economic is transferred to tires, so to say. Yes, we have a network of 70 sorted waste areas in Latvia over the whole country, but as I said, the center is in Riga. Yes, responsible and clear recycling of tires. As I mentioned, we are doing these campaigns where every citizen can come to our location, which we choose each year in different states of Latvia, and they can get rid of it at no cost. Yes, so this is our facility yard where we are processing the tires. They are all getting into one yard, divided by the quality, also by the tires like passenger tires, truck tires, industrial tires, and OTR tires, and sometimes airplane tires from Air Baltica from Riga, which are coming, but that's a headache because they are too big and they are too hard to proceed. We are preparing this material for cement factories and also from Europe companies which are creating different types of materials out of these materials. We have big role and we try to educate every citizen in Latvia to not throw it in the woods, on the ground, everything. Each year we are doing these campaigns. We are driving to schools, teaching kids that this is not a very good material to lie in the nature free. So we are doing visual campaigns in bus stops where we show them where you can visit, what you can learn. Also, the media is very friendly with us, like TV channels, news, and all sort of web pages, everything. We have this "Give Tires a Second Life," this slogan. It's already running for years, and people are realizing what it is. Several hundred tons have been just collected by that. Also, every day we have calls where people call, ask us about tires, where we can get rid of him, what to do. Oh, I have that and this, and we are trying to educate more and more let's say, the consumer what to do and how dangerous it is, because everybody knows if the tires start to burn, it's very hard to put them out. So we are trying to prevent it. Yes, there are some pictures from our actions. There are many kilometers of people standing in cars. Our workers are walking by, asking them to turn off their engines because they are polluting even by standing. But every year we are in shock how many people still have tires. That's the same story like the landfills. They are coming somewhere out and we don't understand because we are managing all the workshops, everything, but still there are tires which are somewhere getting out. Well, the speculation could be there is a gray zone somewhere in the economic, or some not so good businesses which are dealing with something which we don't control. But yes, that's why we are creating to at least to somehow help. But as you see, the citizens are very happy. And each year we have more and more askings for every city in Latvia to do the campaign in their city. At the moment for October, when the winter is starting to come, we have 12 cities already have called us now in September, asked to do this project. So yeah, they can also help their city citizens. There was a very, very hard situation in Riga, in the center, also in the heart, where there were stored for many years 3,000 tons of tires. And it was very hard with the Riga government and with the environment ministry, with us, to get rid of the tons, because the landowner was a different one. It was a really big risk for many years. Fire hazard, like every one fire station was giving attention to environment ministry. Something happens, we are helpless. We can't put out 3,000 tons in center of Riga. We can't get water there. No, there were many issues also from logistics. The cars couldn't drive there. And we took it by ourselves to get rid of it, with our funding, with our knowledge, to, let's say, help our country, because we couldn't bear with it that for many, many years it's standing there and no one can do that. Of course, there were some legal problems from the countryside where they would get sued. The country would get sued, but somehow in the end of 2 years, we were with lawyers, everything, environment ministry found an option to get rid of them. This was the pile, the pictures before. Yes, huge pile. You can imagine if it starts burning, then it's probably you have to evacuate half of Riga, of the smoke and of the toxicity of it. And here we started to clean it out and get it to our facility yard to process them. Yes, so there were two side by side over the street, two lands filled with the tires. Here's already nearly cleaned, let's say one side of it, the other one was in this picture. That's the other side of the street. Yes. So this was the biggest issue. They were laying for many, many years, also from Soviet time tires, which are a different rubber structure as the new, which produced Michelin, Goodyear. There are different types of rubber inside and metal and textiles. So it was a challenge to get rid of them. Yes, here's the pictures after everything is clean on the side. Both territories are clean. It took us nearly a year to do that because we have to collect from all Latvia and also get rid of it. So it was very, very time consuming with extra hours for the workers, but everyone saw the nice thing we are doing. So yeah. Next, textile sorting and collecting in Latvia. Why I'm skipping from tires to textile? Because in tires we are the biggest player, and also in textile we are one of the biggest player. For our companies, when we did something good and right in one waste management category, we have to move to the next to keep the overall, so we can grow. From 2023 in Latvia was the textile collecting and sorting mandatory. The state said you have to start to do it now. So we started to do it. Natural resource taxes is from 1st July from this year. Why it's important to mention? Because in all of Europe it's from next year 1st January. Latvia was one of the first to jump in the train, and as our colleagues in Europe telling me, oh, how it's going, I want to learn from your mistakes, you are the first one. We had a half year in front of everyone, and they are super happy because they see our problems and they can learn. So they have from next year, January, not the same problems. So I find that pretty good because everyone wants to learn from us. So it gives us big opportunity to do something right. Yes, every year it's reaching about 92 million tons of textile every year. So imagine the pile, if you can imagine that in tons, it's a huge, huge mega pile. Yes, and also the textile products imported are each year growing. It's like, let's say, fast fashion trend and more cheaper clothes, and then people start to change them more oftenly, and then yes, so how does it work? The resource tax works so you bring new textiles or create new textiles, you have to pay a natural resource tax. You have a choice, you can pay them to us or to the government. If you pay to the government, it's many times higher than you pay to us. Why you pay to us? Because we do the, let's say, dirty work. We collect it, we sort it, we proceed it, we recycle it, we get rid of it in the way. We get the money so it doesn't go to the landfills. It gets digged in the ground as it was before, and also still is, but a lot less in Latvia. Yes, which are these products? Textile products imported and sold in Latvia, and second-hand textiles. Why it's important to mention, Latvia is one of the first countries in Europe who have put in this resource tax second-hand textiles, because the big countries, I won't mention, everybody knows the big countries in Germany, they are somewhere economically better off. People are more frequently changing the clothes, and these countries are sending them to the not so good countries of Europe because we can still wear it. It's secondhand. It's a good thing, but a lot of these textiles which are coming in are trash. You can't wear them. Some percentage is very good. You can resell them in secondhand. Other, you just have to throw it out. And Latvia government did this analytics that so many secondhands are coming into Latvia, and they are actually half of the textile tonnage responsible of creating, so they tax them. So they have also understanding what they are bringing in, because there were a few loads and businesses where they couldn't even show these documents from which countries they are importing into Latvia. But from the 1st July, of course, they have to do it and show to the system how it gets imported to Latvia, pay the tax, and where it's going, how much is sold, how much you have created trash and waste and everything. Under the resource taxes also we have home textiles and some rubber products. they will still change also in Europe every year. They will add new things which are gonna get taxable. And home textiles also seems weird, but if we have a carpet at home, where are we gonna put it after we have used it, or we want a new one, or it's weird off? Then we have to also tax it so we can get rid of it, because it's the same material as the clothes, just in a different shape and sometimes different material. This is our system of the collection. These are our containers. They are in nice purple color as the pens which were given when we came in. And these are our territories where you can find containers in Latvia. Also, of course, we have competitors which are in the different, but that's okay. It's very nice that we can see what they are doing, what they can do. And for now, we have collected 2,500 tons in these containers. Every year, as I said, it's very different what people put in. In the beginning, there were everything, even tires were put there inside. So we went to the schools to educate. Hey, there are new containers. So they are for clothes, they are for rough clothes, for belts, for everything, but don't put random waste in it. It's doing a purpose in a different waste collection. And yes, also we have in Valmiera. Where are the next speakers? Yes. Yes, what happens to the textiles after we have collected them? We deliver the textiles to our sorting point where we resort them. There are always something inside in the bags. I can just give you some examples like Legos, like plates, like wood, some kind of toys, everything. But it's better that they are in our container, like somewhere different, thrown out in the woods or somewhere else, because we know what to do with it. We make an analysis of the textile quality and already have started to process what is textile. Actually, half of textile is plastic. The clothes are created out of plastic, and that's a big issue from our side and then for the European side, because we tried to proceed it, cut in smaller pieces, and it started to melt. So as we know, how can it melt? So we did an analysis, and there was a lot of plastic inside. Also, many manufacturers, the label on your t-shirts or jackets that isn't what it's written there. So that's also a big issue. Do they cheat, not cheat? Who is watching them, what they put inside? So yeah, but it's now an whole Europe situation. Everybody knows that. And in the future, it's gonna be also what you gonna bring import inside Europe to prevent this, because we know plastics is a big issue, and if we are wearing it, then it gets even bigger issue. Okay, I will go very fast. Yes, we are educating the media about textiles, about what to do, where you can get rid of it and how to do it, because the first consumer is always the most important, the citizens. We are all doing this for ourselves, our families, and the country and the citizens of it. So we try to educate it. We are collaboration projects with shopping malls. They are different containers, but these are in shopping malls. So the people, when go buy new clothes, can get rid of the old clothes. Also, we are pursuing Riga Fashion Week to give the new designers, new minds, opportunity to create something from the old. So this is from old textile, from our containers, a collection, which have created new designers. We ask influencers also to wear secondhand clothes to promote that you can wear it longer and it's not out of trend because of the looks. You can combine it. And with shopping malls, we created a designed carpet out of clothes, as you see, and everyone who was visiting the mall could see that you can create something from new. And it was a big success because we did a workshop where people can in the mall come with old clothes and create new clothes. There were designers and sewing machines, everything, and they helped them to create or to patch something was broken of the textiles. They fixed it, and it was big success. We are doing it every year. Perfect.
Thank you very much. You are indeed doing very important work, because I should say, no, don't go away. Don't go away. We have a couple of minutes. I actually used one of those containers just the other day, but I didn't read which company it was from. So, but next time I'll check. I'll choose yours in that case.
It's okay.
So, any questions? Okay, we have a lot of questions. Good.
Thank you for your presentation. As you are working in both tire and textile sorting, which those are materials that consist of different kind of fractions in different kind of proportions. So it's important that we know what's inside, right?
Mm-hmm.
And we have digital product passports coming up
Mm-hmm.
in the next few upcoming years. What are you planning? Are you planning to implement that in your new facility as well?
Yes, of course, we have to go with time to see what's new happening and go with it. We are also collecting paper, cardboard, glass, every material, but these are the main that I wanted to speak today, as it's, let's say, tires always have been a problem, and textiles is the new, from the regulations of Europe, the new problem, let's say. So about why tires and textiles together, it's a very hard material to process. The tires, everybody knows, tire heavy, strong, and you need big machinery to cut them and clean them. Also textiles, if you throw them in a cutter, it gets stuck because it's a hard material. When you push 4 or 5 layers together of textile, it's nearly impossible to cut it. So if there is also plastics together with textile, even harder, it gets harder. I know that this university knows about materials much more, so I will keep it in a minute.
Yes, thank you. We have another question.
We don't have a lot of time, but maybe you can quickly comment. I know that you are looking into the composites, and maybe you can quickly comment. Do you think it's a possibility that we will have something similar facilities in composites, and when could it be?
Yes, the major problem is you have something to put inside the facility. You have to have these tons of this material so it instantly works. So it makes economically good situation. Yes, so we are looking at it, but as I mentioned, we have competitors, other companies, so we have to sit all at one table and find a solution, because if we are speaking about Latvia, we are a small country and the investment is too huge for a small country, and also if you have to fight for the material, then somewhere it's off. Even the good thinking, green thinking, it gets off. That. Yes.
Okay, thank you.
Thank you.
We still have a few minutes because we had to wait, don't go away. Okay, Zena, please.
Yes, thank you very much for the opportunity, for very nice work that you are doing, actually. I have 2 questions, one related to the textile and one related to the tires. You mentioned that your facility for collecting tires and processing them is actually in the city of, in the middle of Riga city. Wouldn't this impose kind of concerns for the people and for the environment, having an industrial plant in the middle of the city center?
No, because we have regulated tons which we can keep in the yard, and also from the fire department given how to say a scheme where can what stay. We have these big cement blocks, let's say Legos, which are in each Lego pocket is different tons, like it can't proceed more than 10 tons. So if anything happens, it doesn't burn all, it burns by part, and the fire department can get, we have very, very huge control, and every 3 months the environment, let's say, people are coming to check on us if we are doing everything great. So we are under big control about that.
Okay, thank you.
That's
Zena,
assuring,
it's a quick
yes.
question. I will allow it about the tires, but otherwise we are out of time.
It's about the textiles. I'm just curious, is there any taxes for the fast fashion companies actually to have their products in Riga, like the secondhand you were talking about?
Yes, this tax is from the 1st July is to get the database of importers and manufacturers in Latvia, and they are going to, in few years, to get new restriction what they are bringing in to check the material components. So they will have to show what they are bringing in.
Okay, yeah, thank you very
Okay.
much.
Okay, thank you very much.
Thank you.
Indeed, very nice.
Hello, everyone. I'm Līga Bieziņa, and I'm representing Valmiera Municipality government, which is, I think, the only municipality partner within the GlassCircle project, right? Yes. So we are the policymakers on board, so to say. The reason why we joined the project was our aim to support the transition to the circular economy. And glass fiber is actually one of our biggest manufacturing sector, where one of the biggest manufacturing sector within our region. And of course, it creates lots of residues that are at the moment non-recyclable. What is also important to mention, Valmiera is is the second most active municipality in the turnover produced, this GDP which is produced, and from it 25% of the turnover comes from manufacturing industry, and glass fiber makes 11% of the whole. So glass fiber is a very important industrial sector for our municipality, and this is the reason, or one of the main reasons, why it is especially important for us to support the transition to circularity within this field. Because this project is an international project, it's also important to mention that in Latvia, at least, the waste that is being created in our region, in the broader Bieziņa region, it's not in any way incinerated for energy purposes, which is different, for example, to Sweden or other countries where this is as a solution. And therefore, if we do not find solutions for the circularity of the waste that is being created within the glass fiber industry, then the waste is going to our landfill, and it makes the sum up to the waste that is being landfilled and for which we have to pay afterwards. And yes, therefore we participated also to make a share for this project to support this to happen, and we are glad that industry comes together with scientists and really tries to make this network. And thanks to Riga Technical University, who have invited this and have initiated all this. And yes, our share was a minor share. The practical share was a minor share within this project. We made a survey to our inhabitants. What do they know about glass fiber residue? And this survey was made public for the inhabitants of Valmiera region, and also it was distributed among the project partners and their networks. So I'd say this wasn't, in scientific terms, it wasn't a really scientific survey, but still it gives an insight about what our inhabitants think, what do they know, and we can also compare the results from other countries to the results from inhabitants of Valmiera region and maybe a bit broader. And yeah, my presentation is about the results and what we have done within the project. Yes. There were two survey polls made beginning of March this year, and the survey was available for 3 months. And the survey was made in 2 languages. One was in Latvian, the other one was in English. And therefore, my presentation also contains of parallel 2 informations provided. One is the answers from Latvia. We gained 90 answers from Latvia and 56 answers from other countries. And then here you can see the gender share. In Latvia, women were more active, and in other countries where male were more active. Yeah. About the educational level, we also see most probably it was related to the scientific networks in other countries through which this survey was distributed, because the doctorate education, the share of doctorate education is much higher in other countries who took part, for the respondents who took part of this survey than among the Latvians, but also the Latvians were quite educated. So educational level but the background is good. And we cannot say that the answers are because of uneducated inhabitants. Place of residence. So most of Latvian answers are coming from Valmiera district. In Valmiera district, Valmiera is the major city, and then we are having other smaller cities, Massalats, Ujena, Sedas, Trenči, which is the blue is for Valmiera, the red is for the other cities, the yellowish is for also other parts of Valmiera region, and then outside of Valmiera region are the green answers, the 22% one, yeah. And then regarding the international survey, you see also the whole share of countries. Half of the answers are coming from Denmark, then 21% from Sweden, 8.9% from Poland, and then there are also other countries there. And then in what field are you employed? There was a question also about that. From the Latvian answers also, because Valmiera region was mostly represented among the respondents, then also it's visible within this answer, namely 8.9% of the respondents are employed in the sphere related to the production of the glass fiber. And this is logical because Valmiera is having this high share of glass fiber manufacturing industry in our economy. But of course, other sphere is much greater, in much greater share represented. In other countries, direct connection to the glass fiber production is lower, but greater is the sphere related to the use of glass fiber in or its products in raw material in the production process. Then, is waste sorting carried out in your household? It's one of the basic questions, which seems quite logical, but still the conclusion to which we in Valmiera municipality have come to, that it's actually not so logical, unfortunately, because we still face many households who are not, or many also companies who are not taking this seriously, and still the share of households and share of non-sorting waste is quite high. Despite, the answers are also showing this 85% are sorting in Valmiera district, or among the Latvian respondents, and 14 still are not sorting. In other countries, it seems, to my opinion, the share of sorting household waste could be still higher. It would be good. And then there were questions, name any products or objects that are made using fiberglass that you know. This was a question related to the general knowledge. What do we know about glass fiber as such? Because we as customers, we as households, we as inhabitants, of course, are using different kind of products in our everyday life. But do we think about them in general? What are they made of? Where do they go? And all these kind of questions are important because when we think of circularity, our aim as a municipality is to promote and to make this transition to the circular economy. And only by making this awareness building and paying attention to these details are the way how we can promote it. And yes, then here come the answers, boats and wind turbines. It's good that people know that wind turbines are also made out of glass fiber and other materials. You see, there are a lot of them. I won't read all of them, what are mentioned. Maybe one more thing to mention why it is important, especially for Valmiera region, to think about circularity and finding solutions for glass fiber materials. In Latvia, whole Latvia is trying to make a bigger leap to promote sustainable energy. We saw the previous presentation from Hitachi, where also the presenter said that it's important to think about green energy and sustainable energy is our future. In Latvia, at the moment, we are having the process that wind energy is being promoted, and we are facing real resistance towards it, and there are different kind of fights in the public in the media and all this public sphere ongoing. In having all this in background, at the moment, also Valmiera region isn't staying neutral. There are several bigger projects that are in the process of having the wish to be developed. The big windmill parks are hoping to be developed in Valmiera region. So and within this discussion about to be or not to be for this windmill park, there is always also from the opposite side, there is always the question, what will happen after the windmill will finish its functioning? Where will the residues go? Will you have a solution for it? And then what I have heard from the public discussions, there is always the answer that despite at the moment we do not have a clear solution for the windmills, we know that there in this sector there are very active research ongoing, and that by the time when these windmills will have their end of life stage, their solution will be there. So there is a must that we have to achieve this goal. We have to find this solution also from this perspective. So people know about these kind of products. And then there was also a question, select the items you know they contain glass fibers. And then again, the answers here are in Latvian. The same question was also given to the English survey poll. Most of the people know that glass fiber is within a different kind of boats and yachts. People know that also in construction and building sector, 74 is for boats and yachts, and 85% for boats and yachts, and 79% is for building materials. And then, car panels, wind generators, 60% of the respondents know. Airplanes, design products, heat insulation, space technologies, design objects, and also for military, there are the answers. Regarding the other countries, again, most of the respondents know that various boats and yachts contain glass fiber as a substance within the project, within the product. Then 61, the answers are quite similar, I'd say, maybe a bit different, but still the percentage, the share is quite similar. Maybe these answers, because here were given already the answers, people during the survey, people could read the answers, and then this maybe served for them as an inspiration also for answering the later questions. Because in the later questions, there will be also questions given to them. What do they know about, do they have ideas for recycling? But now the next questions was, do you have anything in your household that contains the fiberglass? And in general, people, if in previous question there were the general questions, then here this question comes directly to my household. And when I'm asked directly to my household, then not so many people know the answer. Quite a big share is among the people say they don't know. Because this is, I'm not, no, I cannot say that it's for sure so, but because most probably it's so that because in Valmiera district is this glass fiber factory present. In Valmiera district we are having quite a lot information in general about glass fiber companies. At least also in the circle of municipality and in municipal communication, we are always proud of our manufacturing companies. So this information is somehow given to the inhabitants, at least through municipality. And then we assume that this is maybe the reason why inhabitants from Valmiera region, from the Latvian, are more aware about the products that containing fiberglass in their households than the respondents from other countries. Did you know that there is a large glass fiber production plant in Valmiera? This question is, of course, only for Valmiera, for Latvian opinion poll. And of course, yes, most of the inhabitants know that there is this large glass fiber plant in Valmiera. And then an interesting question is, what is your opinion? And for us as a municipality, is good news, people are positive, having positive attitude towards it. Either it's positive 70% or no opinion 23%. The share of negative opinion is quite low. Of course, we cannot make any conclusions. What's the reason behind these negative answers? Is there a fiberglass factory near where you live? It's a different question. Of course, most of the people say no, 87%, and 30% say yes. What is your opinion about this factory near where you live? And again, good news is that there is no negative opinion. It's either positive or no opinion. Still, it's a question what lays behind this no opinion and how can we interpret these answers? What kind of conclusions, if any, can we draw out of it? Because having no opinion, yeah, it's good that people are proud that with this factory, and we as a municipality are often in the situation that if a manufacturing company is, if we are searching for a place where to build a new factory, or also the same relates also to the wind parks or any of these kind of big companies or big industrial sites, people are mostly negative. It's good to have. It's good to have industry. It's good to have development. It's good to have sustainable recycling of materials. But please do not do it next to my house. And therefore, also the answer no opinion to me as a representative from municipality is rather a positive response than a negative response. No, this is how I see this question. Do you know what surpluses occur in the glass fiber production process? In other countries, 82% of the respondents have said no, they don't know. In Latvia, also more than half, 62% don't know what surpluses occur in the glass fiber production. To me, again, this answer seems that circular economy is still having a field. It's a field where we have to work on. People are not so aware, and to make this transition, there is also this share of awareness raising necessary. Have you heard where it is possible to use the leftovers from the fiberglass production process? It's again a tricky question knowing the background, because there are not so many options where to use the leftovers, and the solutions are not always there. Still, we are proud in Valmiera that there is this ecosystem of companies using glass fiber materials, and that our company is active and eager to find these solutions. But inhabitants, of course, haven't heard where it's possible. Most of the inhabitants haven't heard where it's possible to use the leftovers from the fiberglass production processes. And the answers are different between Latvia and other countries, but still most of the answers are negative. No, people haven't heard where it's possible. Do you know of a company that uses a fiberglass as a raw material in their production? 37% of the respondents from other countries have answered yes. And if they have answered yes, then they are mentioning some of them. And then there are some names of them mentioned, like Bavaria Boat Company, Bühler, Isova, Oasis, Siemens, Vestas. But still, more than half of the respondents don't know any company that uses fiberglass as a raw material in their production. In Latvia, the same question compared to the other countries, it's very similar. 60% haven't heard about these companies, but from those 40% who could name and could answer, yes, I know these companies, have mentioned different kind of companies that are located here in Latvia. Proposals, 3 minutes. I'm close to the end, yes. Proposals for reuse or repurpose of glass fiber production waste. We can group them in 3 groups. Most probably they were inspired from the previous questions, because the 3 groups are construction and building, to work in this field, create new products, and also general ideas, saying actually no clear answer, I'd say. So do you know of a company that uses waste surpluses of glass fibers in their production? Also, these answers that are given are rather unclear. People don't know many of these companies. And then, yeah, the main conclusions is that most of the people in Valmiera are aware of glass fiber production in Valmiera region. Few are aware about the glass fiber ecosystem. There is little knowledge and information on glass fiber products, their characteristics and the related challenges, meaning the circularity challenge and the surpluses that, especially for us in Latvia, we do not, we are landfilling them mostly. But the good news is that the attitude from our inhabitants is rather positive towards glass fiber factory, and we as municipality see it also as a good thing, because we are promoting we are proud of our companies. And still, the conclusion from this is that transition to circular economy is related to complex factors, and still there is a lot of work needed in awareness building. Thank you.
Thank you very much. Very nice, very interesting presentation. Before going, we have a couple of minutes for questions. Before going there, I can say that we actually do also we had this survey in Swedish.
In Swedish.
Yeah, but
Great.
I don't know how many answers actually that one gained. And another comment about the gender equality. Actually, if we put everything together, I think we got the gender equality.
We got the gender equalities. Yeah,
One
exactly.
more target achieved.
Yeah.
Okay, please.
Perfect.
Any questions? Maybe I can start.
Zainab.
Oh, Zainab. Okay, please.
Well, thank you very much for finally knowing the answers for the survey and how people have responded. But I have 2 general questions. First one, do you think really the number of respondents is enough to represent the answers, or to generalize it to the population of the countries or for the areas that you are referring to?
For the whole country, at least what I can tell about Latvia, no. For the whole country, it's for sure not enough. For Valmiera district, a general representative sample would be if we would have gained 300 answers.
And we had 60 something, I guess, or was it 80?
So it's less. It's less. Yeah. It's not scientifically representative, but still it gives a glimpse.
Of course,
direction. Yeah.
But then it comes the real question related to this one: why people are not really encouraged to answer surveys? What do you think? What is the most challenging part? Because I have heard also on the news the other day, it's a real challenge to collect answers to surveys. Do you have any opinion for that?
There are many surveys being made, and at one point it seems as a play, and it's interesting to answer questions to the surveys. But on the other hand, people, there is so much information everywhere that it's difficult to catch attention for a longer time. And the more complex the survey, the more difficult it is to get quality answers. and people, no, for at least how it was made in Valmiera district, it was made, the survey was promoted through municipality communication channels, and people consume them when they have spare time, and of course they are eager to get new information, but then people like to have, if they are involved, they like to be involved in an easy and attractive way. They do not like to think too much or to be too heavily burdened with this survey. And this is maybe the challenge, how to make it easy going. Maybe to collect the answers pieces by pieces would be a solution.
You need to offer a carrot, you know, to motivate.
Or a carrot, exactly.
Like a
Yeah.
lottery. I mean, each survey is a ticket for the lottery. So.
For example, yeah.
Yeah,
Okay.
that's a good. Thank you very much.
Thank you.
Thank
Any
you.
other questions, comments? I have one question about the being positive or negative towards Valmiera's children. Because what do you think? It may be that people are positive because economically it's good to have such a, I mean, it's employer and all that, but they didn't think really about environmental issues, or how do you see
I
it?
think so. You gave the answer.
Okay, so
Mhm.
maybe that question should be also divided in sub kind of categories. Are you happy because it's economically? Are you happy because it's environmentally or something like that? Because I mean, it depends, of course, what we want to know. But
Exactly.
in this
Yeah.
case, I guess we are more environmentally oriented. So I don't know if we got our answer or not, but.
Right. You're right. Yeah. This is still a field where we could research, elaborate more.
Okay.
So next speaker is Pirjo, Pietikäinen. I hope I didn't butcher it. But she's from Finnish Plastic Industries Federation, and she will talk about composite recycling in Finland. So the floor is yours.
Thank you. I haven't presented too many times in Zoom, so I hope I'm successful in sharing. Here
We
we
see your
go.
screen.
Okay, very nice. So my title today is the composite recycling in Finland. And in the beginning, I hope you can excuse me of my not so clear voice. I have terrible flu on, so I might be coughing and that kind of thing, but hope I can get my message clear. So as we speak about composite recycling in Finland, we call it Kimura in Finnish. That is an abbreviation of words collected, shredded composite waste from waste for co-processing in cement industry. So nice discussion with Anders that I heard in the last presentation about reasoning why to do this and is it good or is it bad? But of course, discussion is always welcome. Anyway, I'd like to start with a bigger picture here. So this idea of circular economy model must be familiar to all of you, but we drew this kind of a picture in the beginning of this Kimura project. So there are these yellow operators, then there are processes to take care of, and then some material points of view. So always when we think about this circularity, we start with the materials so that there is a material supplier to supply the materials for the composites. And then some parts are made. And of course, the circularity starts from these material selections, but especially then from the industry and then the users who use these products. So there is a production waste, and then there is this end-of-life waste. This has to be collected, and I think this is one point that is most crucial here. Without this collecting system, this system would be very invalid, as I would say. So that somebody has to take care of the collection, and I think this is a benefit of Finland being such a small country, that this was reasonably easy to solve here. When you have collected the material, you have to do something about it, especially since at least when we speak about composite products, they are quite big, so that you have to cut them into pieces to be able to recycle them with whatever technology. Of course, in here you have to be responsible for these dangerous wastes and materials that can't be taken into the recycling cycle. But when you have selected the right kind of material, you choose the technology. And since we speak about our Kimura here, the cement clinker production is the process where we take the material and get some raw material for cement and then energy to produce the cement. So we started with a project, but today we have a route. We have had it for 2 years now, the ready route for recycling our composites. The initiative came from industry. So we started this in 2020, but to be fair, we couldn't make it this sort of whole with one hit. So there had been 2 previous projects where this has been, composite recycling has been sort of exercised. One thing that in Finland we have there in background is that we have had landfill ban for organic materials since 2016 already. So organic materials can be taken to landfill, but you need some special bureaucracy so that you have to ask permission from local authorities to do that. And as you can understand, these special sort of treatments, they are stricter and stricter year by year. So what we've been doing, 2023, Kimura route took 1,000 tons of waste, and this year we expect 2,000 tons. Of course, when we think about the general amount of general waste, this is not very much. So that whenever we are developing these composite recycling systems, we have to remember that this industry isn't extremely large. So we have to be able to recognize the limits. We started from the waste from industry, from companies that produce composite waste, but we had a possibilities to exercise with some end-of-life products already during when the Kimura was a process, not a route. So there were a couple of windmill plates we got into the system. We rehearsed with them. Then there has been some smaller boats, some process pipelines, gas bottles, and skis. So some products from consumers too. And if you think about all these end-of-life products, there are special things to look at in them. The windmill plates are extremely big, so there must be some challenges according to the transportation solved. Boats most often in Finland, the owners of the small boats don't take them to recycling. They just leave them to some bushes in the seaside, and somebody have to collect them there. The process pipelines naturally have to be clean enough to be handled as a cement raw material. So very versatile material and very versatile challenges we are having here. As you've discussed already today, so that there are several technologies for recycling of composites, and sorry. These blue ones are the ones that are in industrial scale doable today. So the mechanical grinding, and then you mix the material with something else. I think Anders was speaking about this when somebody asked about the second and the third cycle. You get a composite out of composite, more complex material than the material in the beginning was. And then the co-processing in cement industry is technologically and economically possible today. These pyrolysis and other solvolysis and other processes, they are coming, they are developing. But in big scale, this mechanical grinding and co-processing are the technologies that can be used today. So something about the cement route. I hope you haven't heard this too many times, but something I would like to underline here, that I hope all of you understand, that when we speak about cement route, it doesn't mean that we crush the composite and then we mix it with ready-made concrete and get this kind of a composite. But what we mean about co-processing, we mean that we put to the crushed composite material to the kiln where the clinker is made, and the glass fiber there will be used like a limestone and sand as a raw material. So in 1450 degrees, the glass fiber is atomized, and then it's formed again to in the form of silicates that are like the limestone and sand used in the material, in the clinker. The big benefit here is that there won't be any ashes left. As you know, that when you burn the cement, the concrete or the composite in incineration, so there will be the fibers form ashes, and they are the big trouble then, how to make the ashes, what to do with the ashes. But here no ashes are left, so the material has totally disappeared there. And one question here has been that, are there certain cement grades having, so that these kind of a composite grades? But no, there aren't any composite grades of a cement, at least for Fincement here, since the composite is a part of these raw materials, and they are taking care of the recipes in that way that it's a raw material as anything else. So you can't buy a cement bag and then you can't say that this is the composite grade. Maybe somebody are sorry for it, but I think that this can be a big benefit too. And whenever you have good time. This is a very nice video in YouTube where Ursula Kääntee from Fincementti is discussing with Kim Sjödahl from Excel Composite, and they are explaining the cement route very nicely. When we visited, the video was made when we visited Fincementti site. If I remember right, it was 2023 summertime. But yes, so composite as a raw material, composite is not used as any additive or filler in a concrete. Himura route has been very much has risen very much interest also internationally, and I've had nice possibilities to discuss about this cement route or with many people. So, and these are some of the issues we have spoken about. So the amount of composite is too small. For example, at United, in UK, they think like this, the cement industry there. Yes, I don't know if it's a goodwill of Fincementti, but for them, they want to put an effort also to this small fraction. And one thing here, so that the amount of this composite is small. So of course there is this resin that produces energy for the burning process there in a cement kiln. So this plastic can't solve all the need for the secondary fuel in the process. So the dust in processing, so in Finland, it's the recycler here who crushes and shreds the material, who takes care about the dust, not the cement industry. And I can say, after visiting the cement plant, there was a lot of dust. And I think not all that, or even small part of it, had come only from the composite. Then we have spoken about transporting the big parts. Of course, there we have to solve the problem. How do we do it? And these mobile cutting systems are developing quite quickly. And to speak about these cement processes, I hope you can recall now that there are not only one type of cement process. There are different kind of processes. For example, in Finland, Fincementti can take carbon fiber, small amounts of carbon fiber with a glass fiber, but the German process that I know can't take any carbon fiber. Instead, the German cement process that I know, it's not so allergic to PVC that it can take a bigger amount of PVC in it, but Fincementti in Finland can take only minor amounts of PVC into its process. That whenever you start to speak about the cement industry, about your waste, then you have to recall that there are different kind of processes. Something can take something and the others might then be different. Some practicalities here in between. So that what does the composite industry making those products, how does it start its composite recycling? So that you have to collect the composite in different bins than the normal waste or the energy waste you have. You might like to have a big dumpsters outside, but they have to be covered because cement industry wants the material to be clean. and to be dry when it gets the material. And then these transportation to recyclers, because it might be so that your own energy waste goes to somebody else than this composite waste. It might be complicated, but many companies have found it not too complicated. And as anything is changed, we need clear instructions for workers, and sort of it's important to go and check the bins in the beginning so that does everybody really understand what is going into the system. And here is an example of a list used in Finland that what can go in and what has to be discussed with the cement industry, and what are certainly definitely no-nos, because in those first trials we had in Finland, there were actually clothing and there were bicycles and whatever kind of waste. As the cement industry representative said, that there were such a stuff, so that if you think about clothing and shoes and whatever, so that she was expecting that when does the person actually come there, but luckily not such a case was experienced. But as the cement industry learned about this, that they gave us very strict regulations that what can be taken into their processes. They have such a strict recipes, and they are proud of the quality of their cement, so that they don't want the composite to ruin the material process. So as I've been telling you that Kimura, it works nationally. This map, I want to keep it here even though it's not updated. In the beginning, we had only these 7 points of collection for the waste, but today there are 17 all around Finland. They are the recycler is doing work in optimization, the shredding and crushing processes. Piencementti doesn't have to do too much else. They are running their system as they do. The thing that we are looking forward is then how could we get to the consumer products, but it is a big thing to be done. A couple of words about the future, or something about the actually today, since this project, our recycler Kuusakoski, just last week they got this new shredding process working, so that now they have even bigger capacities in taking this composite waste, and it's wise for them to be ready, since we are a little bit late from other parts of Europe, in Finland about the wind industry. So the bigger amounts of windmill plates are coming to circulation in 2030s, but Kuusakoski is ready for that. And what I can say about how the industry has taken this, so half of the composite companies are in Kimura. And if you think about the amount of the composite companies, but it's important that all the bigs are in. So industry is has very much welcomed this possibility to recycle. And to finalize, I want to show you this circular picture about circularity. This European Association of Composite Industry, EUSA, has formed this kind of a nice way to look at the circularity. And when we speak about sustainability of composite products, we have to remember that one sustainable property of these composite materials is their longevity. So if the product can be used 5 or even 100 years, it is a big plus for the nature. And thank you very much for your attendance, and maybe there are time for some short questions.
Thank you. Yes, thank you for a very interesting presentation. So are there any questions? No, online? I had a question, but now I suddenly forgot. Oh, yes, I wanted to ask you about this recycling, these instructions. So in order to composite to be used, it basically has to be very, very clean. And it's how easy for the industry it is to actually sort it in this way. And have you had any pushbacks from industry saying, no, this is too complicated? Or maybe you have some comments about that.
I think that the industry has taken this very well, and since all the big ones has been in already in those trials in 2012 and 14, they seem to be quite ready to do sort of. And of course now when the Kuusakoski's new system is ready, maybe some sort of elastic sort of pipings and sheets and that kind of things that are very much formed in the companies, so that they can be, the companies are very much expecting Kuusakoski to take more this composite related waste.
Okay. This seems like a very interesting route that has been developed in Finland. And I don't know if maybe we can say that there is another project which is now in a review. So let's see if that happens, that we will try to have something developed here in Baltic states. So let's see, hopefully for a good result, it will be kind of continuation of this project. Is there any more questions? No. I feel that, oh, Anders, there is a question from Anders. Yes.
Yes, I'm just curious, when you're speaking about the recycling of wind turbine blades, they're using more and more carbon fibers in the blades. Can you remove that, or how, or maybe I missed something, if you have a lot of carbon fibers in the blades that shall be recycled or taken care of?
Now you are speaking about the question that we have to solve in the future, because now when the plates are coming to the age of recycling, they are the old plates with not so much carbon fiber. So that if they are 20 or 30 years old, so that the carbon fiber problem hasn't been in our table yet, but we recognize that we have to think about that.
Okay, thanks.
It's good to know that we're looking not only at current problems, but possible future problems. I feel that, Pirjo, you might want to rest. Thank you again for joining, and I wish you well. Get better soon.
Thank you. Thank you.
And we can now move to Alann Andre. So for those who maybe, if somebody joined just now, we had a bit of shifting due to some time zone issues. But now Alann Andre is here, and he will actually talk a very interesting, he's from Research Institute of Sweden, and he will talk about managing end-of-service composite structures, challenges and case studies with focus on repurposing. So I think it's very interesting study. So Alann, the floor is yours.
Thank you very much. Thank you. And sorry for the delay earlier. Yeah, 1 hour difference that I missed. So, but I'm here now. So let me just share my screen. Here you go. So you can see, I guess.
Yes, we can see it now. Thank you.
Perfect. Yeah, so my name is Alann, and today I will talk about managing end-of-service composite structures, challenges and case studies with focus on repurposing. So I'm a senior scientist at the RISE Research Institute of Sweden, and working a lot with composite structures in general. And since 2018, I've been mainly focusing on research projects related to sustainable management of decommissioned composite structures. So we had quite many different projects only on this topic. I haven't heard the previous presentation, and maybe you already seen these numbers, but I wanted to start here by showing a bit. I mean, the volumes that we are talking about, and this is some numbers from the literature from 2021. But in the world, we have roughly 12 million tons of composite FRP produced each year, and 1 million of GFRP only for Europe. And in sectors like marine, wind, and automotive industry, it's 98% glass fiber reinforced polymers. And this is for the production. When it comes to waste, there is some numbers from 2019 forecast numbers that maybe you have seen as well. And I mean, the sectors that are mostly represented here in the top are the building and construction industry, automotive, transportation, electric. Then we have marine and wind. And for some sectors, it's quite straightforward what type of structure we are talking about, like boat hulls or wind turbine blades. And you see some example on the right side of the screen. But when it comes to building and construction, which is by far the biggest sector. So why managing this type of glass fiber reinforced polymer structures is challenging? First, most of them are made of thermosets resin, roughly 75%. And let's say if you have structures only made of glass fiber and thermoset in a part, then it's already very difficult to separate them due to the chemical structure of them. But in most cases, we don't have only these two materials, we have other materials as well. So this increases the complexity if you need to separate them prior to separating the fibers and the matrix from each other. And if this is, if we succeed in doing that, still the recovered material is not yet able to compete with virgin material. And here we have an example of a complex structure. This is a section of a wind turbine blade. And you can see you have glass fiber, you can have a different type of matrix. You can have carbon fiber as well, as you just mentioned in the previous presentation. Not all blades are made like that. So this is one type of a blade. And then you have balsa wood, you have different type of foam core, you have adhesive coating metals. And in other structure, you will also find, like boats, you will also find a complexity as well in the structure, not only fiber and matrix. So, so today we are missing. I mean, for the circular management of end-of-service glass fiber reinforced polymer structure, we are missing 3 main pillars here. So first, we have the one linked to policies, and they are not in place yet to favorize the circular and sustainable management of GFRP. Then we have the value chains that are not all available. Some are starting to show themselves, but some are just like starting to be initiated. So this is also missing. And then when it comes to technologies, are not always available at scale. And on top of that, we have also the economical situation, which is quite tough because the price of new glass fiber is quite low. And also the cheapest route today, which are incineration and landfill, are not that expensive and are most of the time open in most of the countries in Europe. So this is also something that prevent to choose more sustainable routes to manage these structures. So one way is to repurpose the structure instead of getting rid of them by, let's say, incineration of landfill. And in some areas like the construction and infrastructure sector, it's very good because it's a resource efficient solution. It transforms waste material into resource. It uses material that goes to landfill or energy recovery. We know that these kind of structures are strong and durable, and they're also good because in terms of maintenance cost, they offer very low maintenance cost solution. They replace high CO2 emission materials such as concrete and steel by repurposing them as well in new structures or new products. So today, this was a short kind of introduction, but today we'll talk about the blades, and we have got some projects in Sweden looking to that. So I will focus on Sweden, the Swedish case. Then I will also talk about some kind of innovative concepts that I think will help a faster implementation of repurposing end of service GFRP, with a focus on a pedestrian bridge deck that we've been working with, and then giving some conclusion and future work. So if we just look at the blades and the numbers, we can say that the number of blades that are going to be decommissioned is expected to increase significantly in the coming years. This is for Sweden. You have the same type of graph for most of the countries that have turbines in place or running today. So, and service life, the technical service life is 20 years, but we have seen Denmark's study show that 29 years is also quite standard. So, and today there is no industry and established value chain to secure sustainable management of these decommissioned blades. In Sweden, there we have 5,000 turbines running. So, and by 2030, we're expecting 1,500 to reach end of service based on 20 years service life. So the routes that are available today, we have 4 main paths to manage this. And these paths can be linked to the waste hierarchy in the middle. So we have a second-hand market, which is preferred. So we still use them as turbine. Then we have repurposing, which is also good because we keep the structure as it is and also keep the value of it as much as possible. Then we have the recycling path, which could be mechanical or chemical recycling, and then the energy recovery or cement co-processing as well, which is mostly in the bottom. And if there is ashes left in the last processes, then this will be sent to landfill anyway. So we still have some kind of landfill through the ashes if they are not burnt as well. As you said before, in the cement co-processing, they just disappear. But today we'll focus on the repurposing path, as we believe it keeps most of the blade inherent value if it's not reused as a blade in a new turbine. So what are the numbers again? I showed before. So within 5 years, we are expecting thousands of blades, roughly 7,000 tons. And this is for Sweden. And the numbers are very important because if we link this again to the 3 main pillars that are missing today, and there's one in the middle of the value chain, for potential value chain actors, one thing that is very important is to understand the volumes and also their availability in space and time. And this data is needed to build value chain that are sustainable. So when it comes to Sweden, when and where will the blade be available? So we have made these graphs in a previous project, and you can see that depending on when the blades or the turbine were installed, they will be decommissioned. Well, in Sweden, the first turbine were installed in the southern part. So you see that we can expect between 2021 and 2025. So now the decommissioning is mostly in the southern part of Sweden. And we also have a different number of blades. So these kind of numbers that we have, we can see that if we go further in time, 2026, 2030, then we still see that the southern part is still the part where we will decommission most turbine, but we see that also in the north, we start decommissioning as well. And later on, we will have the north of Sweden involved as well in this decommissioning. So by knowing that, we can, for instance, build value chain that are geographically located where the blades are. Doing that, we can minimize, for instance, the transportation of these blades. Also, I've shown some section of a blade, and I mentioned that there is so many different types of blades. So one thing that is important if we want to repurpose them is to understand the structure of these blades. And here we see that there is a lot of different types of blades in Sweden, a lot of Vestas blade, and also if we look at the time, they are not the same type of turbine or blade that will be available in the commission. So this is also something that we need to have access to in terms of data. Also, what we need to have to be able to accelerate the repurposing of this blade at scale is to have a robust certification process. To understand how to sort this blade, how we can test them to separate or to first detect defects and separate them in terms of quality, and label them to be able to trace these blades for, if they are repurposed in, let's say, bridge or facade elements, to be able, when these structures reach their end of service, to be able to know what we have for the third cycle, for instance. And all of this data need to be stored somewhere in a database. And this is a very difficult work to do because there is so much different data, and we need to understand what type of data we are going to need. So here I try to represent, and maybe some data that are produced are missing here. But during the service of a turbine, you have a lot of data produced that may be useful for in the value chain after the blade is decommissioned. So these data that are produced already today and exist, we need to understand what they are and how we can use them. And also, when the blade is taken down, what type of data should be produced in order to certify them, and we need to check the status, and what type of value chain will be built, and will you repurpose this blade, and what do they need? So it's a lot of data that are needed, and these data will surely accelerate the repurposing of decommissioned blades. So and also when we have this data in place in a database, then we need to give it access to people. The one that are needed them need to access them in a user-friendly way. So we have also been working with developing a digital platform to understand what is needed and how we can add tools to facilitate the access to data, and also maybe the cutting of the blade, understanding the structure of it, and running some simplified numerical analysis, for instance, to be able to decide, for instance, on site where to cut the blade if you want to use a section of this blade as a girder for a bridge, let's say. So, so this was for, data collection, and the availability, I would say, is very important. It's a cornerstone to repurposing, because there we want to repurpose the blade. So we have an interest in understanding the structure as the mechanical properties and other information for repurposing. So the second point I wanted to talk about today is about how simple and innovative concept can help in the repurposing path. And here I will talk about the concept of pedestrian bridge deck system. So this was another project where we were looking into not into blades at time, but other type of waste stream from two partner of a project we had. And in this case, it was production waste. So we're talking about brand new material and high quality material. And the current end of service that was for this is landfill or incineration. And our focus was to look into trying to develop bridge deck system or balcony or wall elements. So in one case, we had GFLP pipes from our partner in Sweden Hitachi, and these pipes were meaningful landfill if they don't pass electrical insulation test. So, and they are structurally very strong, but if they don't pass this test, then they can't be used as insulators. So here we have strong and high quality GFRP pipes, but also of different shape, of different size, diameters, volumes, unpredictable. So we had some kind of challenges here, but we had a good knowledge of the structure of these pipes. On the other hand, we had GFRP composite sandwich structures that are obtained during the manufacturing of composite bathroom pods, cutting the doors or during some openings in the walls was creating this manufacturing waste. And our objective was to try to find a solution to give value to these sandwich structures that were discarded since they were not useful for the final products for the bathroom pod. So what solution did we have? So we needed to go through brainstorming, but we needed first to understand what are our objectives. So our objective was we knew what this material waste source was. So we need to develop a resilient design, deck design. Our principle was the KEYS principle. And as I say, we need to get things simple because we believe that this is what will bring us forward. So the key requirements was to accommodate various GFRP pipe lengths and diameter, and also availability. For the sandwich panels, we knew it was like a kind of constant dimension, so this was not an issue. The challenges was the unpredictability of production waste, exact nature and volume, as I said before. So the solution for us was to create a flexible concept to effectively utilize the pipes of varying dimensions, both lengths and diameters. So this was a picture from a brainstorming session. So we were like drawing, trying to understand how should we cut that? What are the deck looking today? The kind of bridge deck system and composite, and trying to both knowing the material that we had and how the decks should be built, try to find a solution for our new concepts. So we came up with a sandwich panel, which was, we were slicing then the pipes. So because this gave us the possibility to be able to use them as core elements in the sandwich structure without, with any type of dimension, basically. The length is not a problem because it was sliced, and then the diameter was not either a problem here. And we tried different type of arrangements as well, but this was not influencing the stiffness at all. So we manufacture these panels. You see, it's quite simple, a two-step assembly, just bound with adhesive bonding, and we use adhesive bonding because we didn't want to mix too many different materials. We're thinking of the next iteration as well. So this is adhesive bonding and press. So it's a very simple production method. And we produced a couple of panels, and we tested them in bending in our facility at Rice in Sweden. The light of this panel was 35 kilo per square meter, so it's quite lightweight structure. And the design load for this was equivalent to a golf cart, so 15 kilonewton roughly, because we wanted to use this panel in a deck structure for a bridge which was on a golf course in Sweden. So, but when testing that, you can see that we tested it to failure. We did also some cyclic testing as well, loading. And you see that the failure was quite high. It was 3 times the design load. And we didn't see any deformation before 30 kilonewton of loading. So it was very strong and stiff. And the final failure was not was, as you see here, shear failure through the top and bottom skin of the sandwich panel. So we are very happy with with this concept and the performance, mechanical performance of this concept as well. So we've continued and developed, manufactured more panels, and then we needed to find also a way to how to assemble these panels together. We developed a small bridge prototype, and for the girders, again, we with our partner Hitachi in Sweden, we got some electric poles that were also discarded from the manufacturing. So these poles were aiming landfilling, and they were used here as girder. So here, apart from the metallic fasteners and connectors that you can see, all the material was material that was aiming either incineration or landfill. But by combining them together and finding a smart way of building deck design or deck concept, we could build this small pedestrian bridge. So the span was 7 meter, weight 1,240 kilos, and the height from the top to the bottom of the girder was roughly 400 millimeters. And here you can see on the left part that we had to combine different diameters, and this was actually the objective of this design, to be able to combine different diameters together due to what was available basically from this time in the production. So in a more recent project, we further developed this concept, and instead of using the girders, the poles as girder, we used a section of a blade that was dismantled here in Sweden. So it's approximately 6 meter long, or 5 meter long, and using the same deck system that I showed before. So here the difficulty was to find a way to connect this, the curvature of the blade, the curved surface of the blade with the flat surface of the panels. So we had to develop custom-made supports between the blade section and the deck panels. So this is it's only a drawing here, but the actual bridge is right now being assembled. It will be tested, mechanically tested in the coming weeks. So to link this work with the first picture about the 3 missing pillars that I showed, here it's linked to the technology. And for potential end users, one thing that is very important is which products are available and are they good as traditional ones. So here we have to pass a threshold that is related to acceptance and tradition. So what if I buy this new bridge made with this discarded composite instead of buying it in timber or concrete or steel? So for that, we need simple concepts, and this will help pass this threshold. These are the type of application that we can have with these panels. So it could be sun barriers, roofing panels, balconies, or walkways. I read recently that they had they will refurbish many walkways in the northern Sweden. So the advantage of this type of material that again, as I said before, there is very low maintenance cost. You don't need to paint them basically. So it could be a way to repurpose this manufacturing waste. So some conclusion. So we have a large volume of end-of-service GFLP structures to manage, wind turbines, blades, boats. I didn't even talk about building a construction this is a large amount of different products, and the mapping has to be done first to understand what it is. It's a high competition with virgin glass fiber and cheap end-of-service routes like incineration, and policies and value chain are missing for sustainable management at scale. So in this context, repurposing GFAP structure, which keep the inherent value of the composite structure, could be a solution since it's high up in the waste hierarchy. So repurposing blades and also the type of structures that need robust certification processes that are not yet here, and also access to blade data. So here we have work ongoing. We have some projects here, but I know that there is some work ongoing from Green Europe side as well. But more is needed, and also first implementation as well. And also, since this data need to be accessible, so digital platform need to be also created and accessible for all possible actors in these value chains. We also need simple concepts to trigger end user to choose product made of repurposed GFAP. And we also need new policies, which will accelerate the creation of economically sound value chain. We have an ongoing project at RISE. If you are interested, I can send you the link. We started working on that last May. It will end at the end of next year. And also, if you want to read more about what I just showed, you have some further reading in these recent publications here. So I also want to thank you all project partners from the Resina project and the Circulate projects that are the base of the result that I showed today, and our financial support from Vinnova, Swedish Energy Agency also. Thank you very much for your attention.
Thank you, Alan, for a very exciting presentation. So questions? Yes, Robert.
Thank you for presentation, Alan. It was very informative. I'm curious,
Welcome.
how do you foresee the next kind of recycling cycle for this type of structure, like for bridge, for instance? Because, I mean, it's going to be in conditions when there will be probably significant degradation and all that. So what's going to happen, in your opinion, as the next iteration?
Yeah, I mean, we have the theory of other type of recycling processes, like chemical recycling, for instance. It's not that high yet. So what I foresee is that research should continue in this type of processes. And if we have, let's say, a bridge in 50 or 60 years, when we build it today, and in 60 years we need to take it down, hopefully there will be other processes that will be able to take care of it, processes that we don't have in place today. Yeah. Okay, so in a way, it's also kind of a temporary solution, you think, or this repurposing? Yeah, I mean, 60 years still. Yes, exactly. But it is, I mean, I'm not sure, but if we are able to verify the mechanical properties in 60 years and say they are still good, then maybe we can still use, let's say, a section of a turbine blade in other things. Yeah. All right. Thank you.
I see that Anders has raised hand. Is it from previous, or do you have a question?
Yes, I have a question. Thank you very much, Alan. I'm just curious. I like the concept of the bridge, but I think it's still standing in Malmö at Composite Design. Or have it been installed now, or why have it been installed before at this golf course?
This is the acceptance part that I was mentioning before. There was a plan to have it in place at this golf course, but it is taking a lot of time to have things implemented. I mean, Sweden, when it comes to composite in infrastructure sector, is not in the front, I would say, and the acceptance discussion. I mean, the discussion related to acceptance is not about the technical part; it's mostly about how we can get things done, and this is a reason why it is still not in place today. But we have a lot of discussion with different communes, and hopefully we find another place for that. I've shown this picture of the parking. This one on the right, the parking house in Lund. So there is right now discussion in having it in the vicinity of this place, and this is about to be built in Lund. So it's a parking house with wind turbine sections used as facade elements. So hopefully we will have it in place soon.
Yeah, thanks.
I hope.
Thank you very much. I think it is time now to move to the next presentation. Once again, thank you, Alann, for joining and giving such nice presentation. But
you.
now, yes, now, last but definitely not least, I managed to get Aizea, Astor, Hoschen from European Waste Management Association to talk about post-election Europe, a clean industrial deal for a sustainable, competitive and circular European Union. So she will talk about the policies on the European level. So Aizea, the floor is yours.
Thank you very much, and good afternoon, everybody. It's a pleasure to be here with you online. And yes, I will give a presentation about what is going on in Brussels at the moment. I hope you can see my screen now. Good afternoon again. I think it was a good ending from the previous speaker about the need of new policies. So I would like to, as I said, give you a bit of an overview of what's going on at the moment in Brussels. We had a big announcement of a clean industrial deal. There was a big call from the industry for that, and an overall objective to go for a more sustainable, competitive and circular economy in Europe. My name is Aizea. It was already presented. I'm working for FEAD, which is the European Waste Management Association, who represents the private companies working on waste management in Europe. We have at the moment 19 members who are national associations representing the companies in their country. We have been active over 40 years today, so this is a quite old association for Brussels standards, and our speciality, let's say, is that we're covering the entire waste management value chain. So we have this holistic approach to waste management with an integrated concept going from collection, sorting, recycling, energy recovery to final disposal. Our objective here in Brussels is to advocate for a better regulatory framework for our sector, how to achieve the best outcome, both in terms of economy and, of course, of environment outcome. And the final goal is to strengthen the circular economy in the EU. At the beginning of June, from 6th to 9th June, depending on the country, we had European elections. All citizens were called to vote. And here you have an overview of the results. We saw that there are new groups at the right wing of the parliament, while there were big losses for Renew and for the Greens, so for the Liberals and the Green parties. But nevertheless, they still managed to get a coalition. I will explain that later. The current president of the Commission managed to get a coalition for these more traditional parties at the parliament, letting for the moment out the new extreme parties. Here you have a quick overview of what is the timeline. I said we had elections in June, then the parliamentary groups were created, and there was the constitutive plenary sitting. So when the parliament started working in July, and one of the first things they had to do was to elect the president of the commission. This happened on the 18th of July. And then now the groups in the parliament were created. They are working on different committees on environment, energy, industry, consumers, and so on. And the next step will be the hearing of the individual commissioners who will be in charge of the different areas. We will go to that later. As I said, the first task was to elect the president of the commission. Ursula von der Leyen was re-elected for a second term. I mentioned already she managed to get the support by her own political group, which is the European People's Party, the Socialist Party, Renew, so the Liberal group, and the Greens. And she managed to get the support by all these different groups based on her political guidelines, which she published shortly before this vote. In these political guidelines is where we saw her big announcement for a clean industrial deal. The intention here is to decarbonize Europe and to bring down energy prices, but also there is a big call for competitiveness, so to make business easier in Europe, to simplify, to fasten procedures, to allow to invest more in sustainable competitiveness in general. On the other hand, she is also still committing to the European Green Deal, which was the main work of the previous mandate. This she signalized very clearly by committing to the 90% emission reduction target for 2040, which was announced by the previous commission, and it was questioned by several parties, including her own party, if this should be the way to go. She has committed to that, and she has also made a very interesting proposal, that is a proposal for a new Circular Economy Act. So she wants to create a demand for secondary raw materials and to create a single market for waste. At the same time, there is a need to clarify some chemical aspects. The REACH revision was pending last time, so this is also going to be part of the new mandate. And very recently, there was also the announcement of who will be the commissioners. These commissioners are nominated by each member state nominates one, and they will be in charge, each of them, in developing different areas of the political guidelines from the Commission. From our side, there are 4 main interesting commissioners. The Executive Vice President, Teresa Ribera from Spain, she will be the one leading on the clean, just and competitive transition. There is also the French Commissioner, Stéphane Séjourné, on industry, the Danish Commissioner, Dan Jorgensen, on energy and housing, but especially there will be, from our side, a big interest in the Commissioner from Sweden, Jessica Roswall, who will be in charge not only on environment as the previous term, but now this commissioner also got the mandate to work on water resilience and a competitive circular economy. As I mentioned before, these commissioners will be up to a hearing at the European Parliament. It's going to be probably in November, beginning of November, on the 4th of November. Tentatively, they will be asked questions by the MEPs, and then it will be decided by the Parliament if they accept them or not. If they are accepted, the new College of Commissioners is established and they can start working. Once they start working, each of them have already received what is called a mission letter, and it looks like that. And in this mission letter, it is clearly defined what will be their tasks to develop. On the side of the Environment Commissioner, we have a clear mandate to lead on the new Circular Economy Act, also on the zero pollution ambitions, on the enforcement of already existing legislation of the Green Deal, for example, and also to work on the chemicals package. It is also worth to mention that as well in this month, at the beginning of the month, on the 9th of September, there was a big presentation of the competitiveness report by Mario Draghi. This is something that Ursula von der Leyen had commissioned to him already 1 year ago. It had been delayed for several months, and it was finally announced. and presented and published, it is very, very in line with the political guidelines of Ursula von der Leyen herself. And if we can summarize it in 3 main points, we see a big call to accelerate innovation and find new growth engines, again, to bring down energy prices while continuing to decarbonize and shift to a circular economy, and to react to a world of less stable geopolitics. There are 2 parts in this report. One is a general one, and then there is a more detailed one, sector by sector, giving some very precise recommendations and, of course, an assessment of the current state of the industry in Europe. So if we want to maybe summarize in few points what is going to be happening in the next 5 years, we will be talking a lot about the reindustrialization, and here there will be a big focus on clean technologies, which is very relevant for glass fiber, for example, because of their applications on these clean technologies. We will also be talking about strategic sovereignty, so to reduce dependencies, not only in energy, but also raw materials. We will be talking about competitiveness a lot. It should be sustainable and innovative, this competitiveness, and of course, linked to all of this on circular economy. There is a big focus on critical raw materials, but the circular economy should also apply for the clean technologies, because we also, Mario Draghi has identified in his report this as a fast growing market globally. It is essential to reach our climate ambitions, and according to his assessment of the market, the supply is at the moment very highly concentrated, and while the EU is one of the biggest markets worldwide, it is heavily reliant on imports. And so this should be an opportunity to lead innovation in these areas. There are, however, a lot of barriers to scale up on the manufacturing and to compete in Europe. So yeah, here the point would be to really create a more stable and predictable demand for these type of technologies, to be able to develop them here in Europe. And again, here the role of the circular economy is precisely that. Also for the circular economy, we need stable and predictable demand. It is, of course, about improving recycling, increasing recycling, but also about having a strong demand, about having the acceptance and the trust of the market to be able to compete with primary raw materials. And all this needs to be very much in line with eco-design measures that will also be developed in the next years. If we have a look at what is the state right now, in terms of waste management in Europe globally, this is data from 2020, and we see a good point that more than half, so around 60% of the waste is recovered. However, there is also the other 40% which is disposed of. And if we look at recycling within the recovery, we actually see that we have almost same data for recycling than for disposal. And this is something that we need to revert to increase the recycling and reduce the disposal figures. What is also very, very concerning is that if we look at the data in the different member states, there are huge difference. So there are ones that you see with high green levels, which is recycling, and others where the pink bars are almost occupying everything, which is the disposal. And this is also a field where the enforcement of the legislation needs to enter into the play to make sure that all countries in the EU are going in the same direction and that we have a level playing field in the EU. Another interesting figure to look at is the circularity use rate. So how circular is the material that is used in the EU at the moment, how much of the materials we use come from recycled waste materials. You can see here that in the latest figures we have, it reached 11.5, it was 12 at some point, but what is extremely worrying from our point of view is that this figure is very, very stable. You can see it has barely moved in the beginning from 2004, maybe until 2010, it increased slightly, but then since then, for the last more than 10 years, it was extremely stable. And this is also something where we need to work on to really strengthen here the demand for recycled materials. Based on this data, FEAD as industry representatives, we developed a vision last summer where we said that where we need to go in the next future is to really shift the material use in the EU towards recycled materials. And this needs to be done through industrial excellence in waste management because we need to have the trust of the market. For this, we have been putting some targets. Let's say we would like to double this circular material use rate to reach at least 25% in 2030. And then if we talk about 2035, we would also like to reach 75% of recycling. And here we cannot only look at municipal waste, which is a very small part of the waste, but we need to consider all types of waste. In this the mission of our sector is, of course, to supply these raw materials, but also to supply energy, and very importantly, to safely treat the waste, again, to have the trust of the market and the consumers. Based on this vision, we have also developed a manifesto. We did that before the elections, where we joined the industry call for an industrial deal. But we saw this as it has to be an industrial deal that moves Europe towards sustainability, competitivity, and circularity. So sustainability, we need to stick to the Green Deal objectives. And this is something we are happy that it was very well reflected in the political guidelines by Ursula von der Leyen. Competitive, so we want a solid manufacturing base in Europe, and circular. So the material use from this manufacturing base in Europe needs to come in very high rates from recycled materials. How are we going to do this is a big question, of course. We have some ideas, and here we have grouped them in different, in 6, let's say, headings. This industrial production or the reindustrialization of the EU needs to be aligned with the circular economy. This means that if we are increasing our industrial base in Europe, we need to also increase and scale up our recycling, collecting and sorting capacities in Europe. We need to be able to adapt, of course, also the waste management sector to the industry in Europe at each moment. On the other hand, I have mentioned it several times, the demand. How can we strengthen this demand? We need to have some economic and financial incentives. We need to be able to compete with primary raw materials, which at the moment are cheaper than recycled materials. So how can we do that? It has worked very well with mandatory recycled content. So this should maybe be something to be extended to more materials, but also we want to push strongly for having more green public procurement. So we know the public hand has a very big purchasing power, and they need to be the one leading by example and purchasing sustainable products containing recycled materials. Another point is on the climate aspect of all this. So we know that recycling saves CO2 emissions from the extraction and the processing of raw materials. This is, however, not recognized, and this is something that we would strongly like to be considered, so that there is again another type of incentive to go for recycled materials instead of virgin materials. We also need to strengthen our autonomy in the supply of all resources in general, but also for recycled materials, because we had recently some big players, especially in the plastic recycling sector, that went bankrupt because they are competing with the very, very cheap recycled materials that are imported from outside the EU. And here we do not even have the certainty that they are recycled. And of course, we do not have the certainty that they are applying the same environmental standards than us in the EU. So this is something we need to work on to require this level playing field with the imported materials. Enforcement, I have mentioned it. We have rules, but we see that they are not equally applied across the EU, and this is a problem for us to grow. And we need to make sure that the rules are implemented and that they are enforced across all member states equally. And finally, we need to ensure a competitive market for waste management. We need to be very careful with restrictions such as to accessing materials, or that we have issues entering some markets because there are some preferential treatments for, let's say, publicly owned companies. We see this especially in some specific countries in Eastern Europe. So this would be the 6 main areas where we would work on as a federation. And if we can conclude on something for the next 5 years, we need to work a lot on good policies, new policies. We need to work a lot on investing and on innovating. We need to be able to shift towards this sustainability, competitiveness, and circular economy. And this needs to be done through more eco-design. So we need to put better products on the market that are recyclable, but also that contain recycled materials. We need to increase recycling in quantity and in quality. And we also need to make sure that we are treating the residual fractions in a safe and environmentally responsible way. Thank you very much for your attention, and I will be happy to receive your questions, as well as if you have any ideas you would like to share with us. We will be working a lot on the new Circular Economy Act, so all ideas are welcome.
Thank you. Thank you for a very interesting presentation. Questions? Online, maybe somebody? No, so I will have a question. I have several questions, but maybe more philosophical. How do you see how academia and industry can help? And maybe something, what maybe where is the biggest pushback, and where you can also improve to have this, because I really think if we all three work together, academia, industry, and policymakers, I think the change can happen much quicker.
Yes, thank you for this question, and indeed that's very true. We have there is a need for innovation, and here, of course, academia needs to play a very big role, and we need to have the resources. So where are these resources going to come from? They need to come from public investments, but also from private investments. And here, this collaboration, it needs to work very well. We will need this, for example, very strongly for recycling critical raw materials, which will be very important, and it is a sector that is not developed at the moment. So here, these research and innovation partnerships are going to be essential, and we need to have the support by the institutions.
You, maybe somebody came up with any questions? No? Yes, maybe. Oh, Mikael, yes.
Yeah, thank you for the nice presentation. Question is like, are you involved with research projects like, or policy, research projects which they involve policy inside?
We are part of some European projects in the, let's say, board of advisors. There is a project at the moment ongoing where we are advising. Yeah, and we had part of our vision was actually to strengthen these partnerships, and this will be part of our work for the future.
Thank you. I saw that Anders raised hand, but it's now gone. Do you have a question, Anders?
Yeah, I can. Thank you very much for a very nice presentation. And you showed a graph of recycling materials for different countries. And as a Swede, it didn't look so nice. I think we in Sweden feel like we are quite good in recycling, but we were really on the bottom regarding recycling. Can you show that again, these bars showing different countries, incineration, recycling, and maybe explain why we are so bad in Sweden?
Okay, I think you mean this one.
Yeah. So we were really quite far to the right.
Yeah, you're here. Well, this is data coming from Eurostat, and I can tell you it's the official data, but yeah, everybody complains about it. So yes, for us, one of the points we are also discussing a lot is how to collect better data, and especially how to make this data comparable, because we do not think that member states are at the moment collecting data in the same way. So we have these graphs, they are official data. Based on that, decisions are made. But yeah, from the company side, from the people that are in the countries, everybody complains about them. And so, yeah, it would be really important, I think, also to find good policies to have better data and especially comparable data.
Okay, thanks.
Latvia is looking very nice, but we'll see. Birgitta had a question. Birgitta, okay. Yes, Birgitta, you had a question. Maybe not anymore. Okay. Well, if anyone online or on site has any more questions, feel free to either contact directly or.
Yes, as I said, we are always available for any questions, but also for any suggestions, any concerns that you would like to share. We are here.
Yeah, if I may, I would like to still wave Swedish flag a little bit. I mean, is that related, this graph? Could it be that the collection and sorting is good in Sweden, but actually recycling is done elsewhere? Could be that why this graph looks like it is?
I have no more information about how this data is produced. As I said, I don't know any country that is happy about their data, how it is reflected, but at the end, it's the data that the Eurostat has, and it is the official data.
But I think it's maybe Robert is on it, because I think Latvia is recycling a lot of Swedish waste. So. Yes, Scandinavian waste is important in Latvia, and then we recycle. So maybe that's the issue. So you're good. we do also part of the work. So yes, thank you again. Any more questions, feel free to send me or directly to participants. And once again, thank you everyone for participating and listening. I think it was very interesting. At least I have a lot of things to think about now. And before we go, I just wanted to say thank you to people who helped me organize this event, especially Richard. He has been doing a lot. And Karina, she's there, Vineta, and also Robert for helping to find speakers, and Valmiera Municipality also helped me find some of the speakers. So thank you all. And there is farewell coffee. And see you hopefully soon. And now also is a good time to discuss the things we have heard today. So thank you again. And thank you everybody who joined online. It was I was very happy that you all joined, and we had actually, I think, very nice discussion, and hope to see you in the future in projects, workshops, and hopefully for some good collaboration also. So thank you all.
Thank you very much.
Thank you.